Hello everyone and welcome to our first subject, digital logic. So before starting digital logic, let us look at the syllabus that we are going to have. So in digital logic, we have the following topics in GATE. Number 1, Boolean algebra. Number 2, minimization. Number 3, combinational circuit. Number 4, sequential circuit. And number 5 is number system. So we will be starting with Boolean algebra in the beginning. So this Boolean algebra will take us approximately 2 and 2.5 hours, and then this minimization will take us approximately 5 to 6 hours. So this is a very lengthy topic because here we are going to study about the circuit minimization, which includes K-map and other methodologies to minimize a Boolean expression. And then combinational circuit will take us approximately 10 to 12 hours to complete. Sequential circuit will again take us 10 to 12 hours to complete, and this number system topic will take us 5 to 6 hours to complete. So in total, this entire subject will take us 40 to 54 hours roughly, more than 40 hours, because if we include the previous year question solutions also, it should take us between somewhere around 50 to 60 hours to complete this entire subject. And this subject you have also have studied in your BTech in the first semester of your BTech. And if you are from other backgrounds, maybe you have done MCA or you have done BCA or BSc IT, MSc IT. In all of those subjects, in all of those courses, this subject is basically in your first semester of BTech, in your first semester of those courses. So I'm assuming that you already have some knowledge regarding Boolean algebra or digital logic that you have studied in your initial semesters of your graduation. So again, I will take this subject from the very basics. Even if you are out of touch from the subject, still I'm going to take this subject from very basics. अगर आपको सब कुछ आप भूल चुके हैं, or if you are studying it for the first time, still you will be able to understand digital logic. This is what I'm trying to do here. Okay, so we'll start with Boolean algebra. In Boolean algebra, first of all, you should understand why digital logic, why we have digital circuits. Digital circuits क्यों हैं हमारे पास? So it is very important for you to understand that whenever we transfer signal from one location to another location, it can be anything. The signal, you can transfer the signal in a computer network through fiber optics cable, or maybe you want to transfer the signal within a same computer system from one device to another. जैसे for example, you're transferring from hard disk to the main memory or to the secondary memory, something like this. So in all those cases, we use signals in your systems as digital signals. We do not use the analog signal. What is the difference between both analog and digital signals? Let me show you with the help of an example. So if you know that your analog signal looks something like this, your analog signal looks something like this, right? So in this analog signal, the values of this signal matters. जैसे maybe here I'm representing plus 5 volt, here I'm representing maybe 0.35 volts, here I'm representing something like 0.25 volts or something, right? So whatever the value of these signals, these values matters. Now what if there is some disturbance in the network? What if there's some disturbance in the signal? Now if there's some disturbance in the signal, what will happen? This signal will lose its values. Right? So because the values will get affected, so getting the data back, जो data आपका signal से lost हुआ है, getting the data back is very difficult in that case. But rather, if you use a digital signal, because in digital signal we have only two values, that is zeros and ones, right? So most of the time we represent a value 1 by using plus 5 volt, and we present a value 0 by using plus 3 volt. Okay. So your digital signals look something like this, that we have a 1, then we have a 0, then we have a 1, then we have a 0, then we have zeros, ones, and so on like this. So it is not having any other in-between values. It is not having a value like 3.5, 2.7. These kind of values in digital signals, we do not get these kind of values. And because of that, even if the data get corrupted, even if the signal gets corrupted, it is very easy to recover the data from the signal. Let me show you with the help of an example here. So as you can see here, this is the original message that we want to send. It is 01010010. So this peak is representing a signal as 1, and this is representing a signal as 0. So if you want to send this data and somehow while sending this data your signal gets corrupted. So if your signals get corrupted, something like this, some distortions will come up, and because of that distortions your signal will get corrupted. Now, but you can see clearly here that even if we have such kind of distortions, getting back the original signal is much easier. So because getting back the original signal is much easier, so we will not be losing any kind of data. आपका कोई भी data loss यहाँ पर नहीं होगा. You will not be losing any kind of data here. Okay. So that is why using a digital signal is much beneficial as compared to using the analog signal for data communication, right? So in your Boolean algebra, when you studied this Boolean algebra in your college, so this subject is also called as digital logic. This subject sometimes in some universities they call it as digital electronics. In some universities they call it as digital circuit design. In some universities they call it as digital logic design. So there are many names for the same subject. And you have studied some of the basic gates. You have studied some of the basic operations, like you have an AND operation, OR operation, NOT operation, XOR operation, and XNOR operation. AND operation is generally denoted by a dot operator. So if I say we have A dot B, which can also be written as AB, right? So sometimes we miss this dot because it is very obvious that between A and B we have a dot. So this is representing your AND operation. This OR operation is represented by your plus operator. So if you write A plus B, so that means A or B. Then you have NOT operation. So this NOT operation is represented by a complementation operator, right? So it is represented by A complement something like this. So it reverses the value. So if the value is 1, it reverses the value to 0. If the value is 0, it reverses the value as 1. Then this XOR operation is represented by this sign, and this XNOR operation is represented by this sign. You have seen most of these operations in your BTech. Now, it also happens that for different kind of Boolean algebra, we use different symbols, right? So for example, for AND operation, we use dot. We can also use this sign. So this sign is representing conjunction. For OR operation, we can use a plus sign, or we can use this sign which is representing a disjunction. For NOT operation, in some books, they are using this sign. In some books, they are using this sign for complementation. In some books, they are using this single, comma on the top to represent the complementation or the NOT operation. Then we have XOR operations. Right now, just for simplicity purpose, we are going to follow the same notation. For XOR operations, we have different notations in different cases. It's different scenarios and different books. Because it is not necessary that you have only this kind of Boolean algebra. You can have different structures of Boolean algebra. There are many structures of Boolean algebra. Let me explain you with the help of an example here. So first of all, let us see what does these operators mean. In सभी operators का मतलब क्या है? When we do this AND operator, so this AND operator is represented by this symbol graphically. And the truth values are as follows. So if the value of x is 0, y is 0, then the value of x dot y, or you can say x and y, is 0. So if these values only 1 if both of them are 1. जब दोनों इनपुट्स की वैल्यू 1 होगी, अगर इनपुट x की भी वैल्यू 1 है और इनपुट y की भी वैल्यू 1 है, तभी यहाँ पर जो रिजल्टेंट फंक्शन है, जो रिजल्टेंट है, उसका आउटपुट भी 1 होगा एंड के केस में. लेकिन जब हम और की बात करते हैं, इन केस ऑफ और, सो व्हेनेवर एनी वन ऑफ देम इज ट्रू, यानी कि दोनों में से अगर किसी एक की भी वैल्यू 1 है, इवन इफ x इज हैविंग अ वैल्यू 1 और y इज हैविंग अ वैल्यू 1, अगर दोनों में से किसी एक की वैल्यू भी 1 है, in that case the function returns a value true, or you can say 1. And then we have inverter operator. So inverter operator, again, it is a complementation operation. You can also represent it by x complement like this. So in this inverter operator, if you give an input as 0, it will change the input as 1. If you give input as 1, it will change the input as 0. So in the same way, when you look at the other operators here, like here we have the buffer gate. So this buffer gate means whatever input you will give, it will give the same input as the output, but with some delay. Buffer gate means whatever input you will be giving, it will give exactly the same output. Then you have the NAND operator. Now in this NAND operator, it is basically NAND is x dot y whole complementation. It is the opposite of AND. So I just used an AND gate here, and with this AND gate I am using a NOT operator. हम AND gate के साथ एक NOT operator को use करेंगे तो हमारा बनेगा NAND gate. So all the values here, these are opposite of AND. So what I can simply do is I can take x dot y and I can do a complement of x dot y. So that is what the value of this function says. So AND operator was having a value 1 here and all other values were 0, but in this NAND operator only this value will be 0 and all the other values will be 1. Then you have this NOR operator. So in this NOR operator is simply basically x plus y, there is OR operator, and you are going to add a complement on the OR operator. तो ये आप check करेंगे, this is representing your OR gate and this is representing your NOT operation. So OR plus NOT is your NOR operation. So it is having a value 1 when both of them are 0, otherwise it is having a value 0 in all other conditions. इसकी सिर्फ इसी एक केस में वैल्यू 1 है, बाकी सभी केसेस में इसकी वैल्यू 0 है. Clear? So I think you have already seen this in your BTech. In the same way, here we have exclusive OR and exclusive NOR operator. Exclusive OR is also called as XOR, and exclusive NOR operation is also called as XNOR. We also call it as XNOR operator. Okay. So exclusive OR is basically x y complement plus x complement y, and exclusive NOR operator is x complement y complement plus x y. So they have a little difference here. So if I just add a NOT operation here, if I just add a NOT operator in an exclusive OR operator, then it becomes a XNOR. I mean to say, if I take x XOR y, now this x XOR y, if I take a NOT of this one, then this will give us x XNOR y. तो x XNOR y के अगर XOR के अंदर हम NOT operator को ऐड करेंगे, that will give us a XNOR operator. In the same way, if I do x XOR y, then this is equivalent to x XNOR y whole complementation. तो इसके whole complementation के equal है. And if you look at the truth values here, अगर आप इनकी truth values को check करेंगे, then you will identify that this XOR operator is having a value 1 when any one of them is 1 and the other one is true. But if both their values are same, जैसे x की भी value 0 है और y की भी value 0 है, when both of them are having a value 0, in this case the function is going to give us a value 0. When both of them are having a value 1, in this case the function is going to give us a value 0. But when you look at XNOR, so XNOR is basically opposite of XOR. So whenever both the values are opposite, जैसे एक की value 0 है और दूसरे की 1 है, या फिर एक की 1 है और दूसरे की 0 है, उस केस में this function will give us a value 0. Otherwise, this function will give us a value 1. That's it. Okay? I hope it is very clear. इतना सभी के साथ clear होगा. Now, if I take these Boolean variables, right? So if you seen in the previous example, what are x and y? X and y are Boolean variables. Why they are called as a variable? They can take different values or various values. So if you have only one Boolean variable, right? Why? First of all, why do they call it as Boolean? हम इनको Boolean क्यों बोलते हैं? Boolean was the name of the mathematician George Boole. So George Boole, gave these Boolean variables. So these Boolean variables can take two values. That is, either they can take a value true or 1, or they can take a value 0. So they can have only two values. So if you have only one Boolean variable here, जैसे यहाँ पर आपके पास सिर्फ एक ही Boolean variable है, so this Boolean variable can take only two values, which is 0 and 1. तो कितनी values यहाँ पर possible है? There are two values that are possible. If we have two Boolean variables, now with these two Boolean variables, you can take four values. आप four values यहाँ पर assume कर सकते हैं. So the values are 0 0, 0 1, 1 0 and 1 1. So they can take approximately 4 values, correct? And when you have 3 Boolean variables, so 3 Boolean variables means they can take a total of 8 values. The values are 0 0 0, 0 0 1, 0 1 0, 0 1 1, 1 0 0, 1 0 1, 1 1 0 and 1 1 1. They can take a total of 8 values. अगर आप यहाँ पर चेक करेंगे, यहाँ पर इन दिस केस व्हेन वी हैव टू वेरिएबल्स इट टुक टोटल ऑफ 2 raised to power 2 values. When we have 3 variables it took a total of 2 raised to power 3 values. That means if in any function you have total of n boolean values or n boolean variables with n variables, how many such values are possible? ऐसी कितनी unique values possible है? That is 2 raised to power n values are possible. So here with one variable 2 raised to power 1, with 2 variables it is 2 raised to power 2, with 3 variables it is 2 raised to power 3, and with the help of 4 variables it will be 2 raised to power 4, with the help of 5 variables it will be 2 raised to power 5 and so on. तो इस तरीके से इनकी values बनेगी. Okay. Now these Boolean algebra they are having a definite structure. So when can we say an algebra is a Boolean algebra? किस algebra को हम Boolean algebra बोल सकते हैं? When can we say that? So basically a Boolean algebra follows a structure. So this is basically this is a topic in discrete mathematics which is called as structures of algebra. If any algebra is following a certain kind of axioms, then that algebra will be having a different category. हम उस algebra को एक different category में रखेंगे. We are going to call it as we will give it as a name, right? So जैसे आपके पास linear algebra है, right? You have in the same way you have Boolean algebra. So you must have seen that even if we use intersection, union and complement, still it is called as a Boolean algebra, right? तो आपके पास अलग अलग तरह की Boolean algebra है. So how can you say it is a Boolean algebra? Then any algebra, if it is having a certain kind of structure and it is following certain kind of axioms, then we call it as a Boolean algebra. जैसे if let us suppose if we have a set A here and this is a binary operator. Binary operator means an operator that can be used on 2 operands. This union is again a binary operator. This not operator or complementation operator is a unary operator, and here we have 2 specific elements of the set, right? So there are 2 elements here, so this is also a Boolean algebra. Why? And it should also follow all of these rules here. So we'll discuss about them one by one. Then we can also have an algebra like this. We have a set A, we have operations which are dot operation, we have OR operation, we have the complementation operation, we have element 0 and we have element 1. So even if we have in a set A, we have the conjunction operation, we have a disjunction operation, we have a not operator, and now we also have a value which is false and we have a value true. So all of these algebras are examples of Boolean algebra. So what is a Boolean algebra? So Boolean algebra is a complemented distributive lattice. So what is this distributive lattice? We are going to look at it in a lot of depth in discrete mathematics. जब हम discrete mathematics पढ़ेंगे तो उस समय पर हम इन सभी चीज़ों को बहुत in depth में study करने वाले हैं. So what is a Boolean algebra? A Boolean algebra or a Boolean lattice is a complemented distributive lattice which is having these 6 tuples. In these 6 tuples you have 2 operators which are your binary operator, you have 1 operator which is your unary operator, and you have 2 elements of the set. आपके पास sets के 2 element हैं, and then they should also follow these 6 axioms, or can say they should also follow these 6 properties. कौन सी property है? The first property is associativity, the second property is commutativity, third property is absorption, then we should have identity element, then it should follow distributivity property, it should follow the complement property. So there should exist a complement of every element. हर एक element का complement exist करना चाहिए. So if all of these properties are followed, then we can say this algebra is a Boolean algebra. And why writing such properties is very important, because it identifies, it tells what is the properties that the elements or the operators are following. Let me show you with the help of an example. Let me take a very easy example. मैं एक बहुत आसान एग्जांपल लूंगा that will show you what is the use of these operators. इन सबका बेनिफिट क्या है. देखो, if you study mathematics, जैसे आप अपनी कॉलेज लेवल पे या स्कूल लेवल पे आपने मैथमेटिक्स को स्टडी किया होगा, so in your mathematics you have an addition operation, you have multiplication operation, you have division operation and you have subtraction operation. So आपके पास ये 4 fundamental operations है. कौन कौन से? Addition, subtraction, multiplication and division. These 4 operators are there. If you look at associativity property says if we have A plus B plus C, then it is equivalent to saying A plus B plus C. That means you can associate these brackets. And what does these brackets are doing? These brackets are increasing the priority. यानी कि पहले आप यहाँ पर B plus C को evaluate करो और फिर आप A को evaluate करो. And here you have to evaluate A plus B and then you have to evaluate C. So you can say this addition operation is associative, correct? In the same way your multiplication operation is also associative. जैसे अगर आप ऐसा करेंगे A multiplied by B multiplied by C, then it is equivalent to saying A multiplied by B multiplied by C. So your multiplication operation is associative. But if you look at it here, your division operation is not associative. आपका जो division operation है वो associative नहीं है. Okay? So जैसे कि if I do A divide by B divide by C, it is not equivalent to saying A divide by B divide by C. Your division operation is not associative. Let me show you with the help of an example. Let us suppose you have three numbers, right? You have a number 2 divided by 3 divided by 4. Then it is not equivalent to saying 2 divided by 3 divided by 4. So your division operation is not associative. So it is very clear that your addition operation, your multiplication operation, they are associative. In the same way, your division operation is not associative. And you can also check the same property for subtraction operation. आप इस तरह की जो property है उसको subtraction operation से भी check कर सकते हैं. Okay. The next operator here is your commutativity property. Now why this commutativity property is important? So commutative property says if I do A plus B, then it should be equal to B plus A. So your addition operation is commutative. If I do A multiplied by B, then it is equivalent to B multiplied by A. So your multiplication operation is also commutative. If I do A divided by B, then it is not equal to B divided by A. A divided by B जो है वो B divided by A के equal नहीं है. जैसे 2 divided by 5 is not equal to 5 divided by 2. So your division operation is not commutative. In the same way, your subtraction operation is also not commutative. जैसे if you do 2 minus 3, then it is not equivalent to saying 3 minus 2. So subtraction operation is also not commutative. आपका जो subtraction operation है वो भी commutative नहीं है. Right? So you should know what are the properties these elements are following. So let us look at these properties one by one. So what are these properties? The first property here is associativity. So your AND operator as well as OR operator, both of these two operators which are your binary operator, or both of these binary operators are associative. Then your AND operator as well as your OR operator, both of them are commutative. दोनों commutative भी है. Then there exists an absorption law here. So we will look at this absorption law later on because I can show you the same with the help of a Venn diagram. I'll show you. Then there also exists an identity element. यहाँ पर एक identity element भी exist करता है. So here what is this identity element? For OR operator the identity element is 0 and for AND operator the identity element is 1. ठीक है, मतलब identity element का मतलब क्या है कि if you perform the operation with the identity element you should get exactly the same value. आप अगर identity element के साथ operation को perform करते हैं तो आपको exactly same value ही मिलेगी. That is called as your identity element. Just like if you see multiplication, the identity element for multiplication is 1 because if you multiply any number by 1 you will only get the same number, right? In the same way for subtraction, what is the identity element? For subtraction the identity element is 0. If you subtract 0 from any number you will always get the same number. Then you have distributivity property. So we will also look at this distributivity property with the help of a few examples. I'll show you examples से इसको कैसे करना है, and I'll also show you what is a complementation property. So in your Boolean algebra right now we are going to represent every OR operation with the help of plus sign. यहाँ पर हम हर एक OR operation को plus sign के साथ represent करेंगे, and we are going to represent every AND operation with the help of a dot sign. So the first operation, the first property here is called as dominance property. And why these properties are important? देखो ये सभी जो properties है, जो सभी नाम है, All of these names are very important because in your exam you get direct question based on this. You will get some operators, you will get some operations, and they will ask what kind of properties these operations or operators are following. So right now here, whenever you add 1 with any variable, अगर आप किसी भी variable के साथ आप 1 को और करेंगे, then you will always get a 1. If you add a 0 with any variable, you will always get a 0. In the same way, for addition, or you can say for OR operation, the identity element is A. And here for AND operation, the identity element is 1. Here for idempotency, you can see idempotency means if you perform A plus A, you will get A. In the same way, if you do A dot A, you will get a A. When you do complementary, that means if you do A plus A complement, you will get a 1. So this complement represents kind of an inverse element, right? So here you can see for this complementary operation, we have this A plus A complement, then that is equal to 1. For dot operation, A dot A complement is equal to 0. A plus A complement or A dot A complement जो है वो 0 है. Then we have commutativity property. If you do A plus B, then it's equal to B plus A. So this A or B is equal to B or A. In the same way, A dot B is equal to B dot A, or you can say A and B is equal to B and A. So your AND operation and your OR operator both are commutative. The next property is your associativity property. So you can clearly see that your OR operation is associative as well as your AND operation is also associative. आपका OR operation भी associative है और AND operation भी associative है. Then we have distributivity property. So if we have A plus B dot C, so I can distribute this plus sign with B as well as with C. I can distribute it, so I can say it is A plus B dot A plus C. In the same way, here also I can distribute this operator. So if I do A dot B plus C, that is equal to A plus A dot B plus A dot C. Then you have absorption property. So A dot A plus B is equal to A. तो यहाँ पर जो absorption property है, I can also represent this absorption property with the help of a Venn diagram. Let me explain you with the help of a Venn diagram here, right? So we have A dot A plus B. This is what we have, right? Now if you can open the bracket, so this will be A dot A plus A dot B. And if you look at this A dot A, this is equivalent to A only. So this is A plus AB. ये क्या बनेगा आपके पास? A plus AB here. ठीक है, ये आपका बनेगा A plus AB. Now I can show you with the help of Venn diagram here. So if this is representing A and this is representing B, then this area which is common between them, this area is representing AB, or you can say A dot B or A and B. So the area which is common between A and B, that is called as A and B, right? So here in this case, what we are trying to do, we are trying to take this entire A. So ये आपका पूरा entire A है, and we are trying to OR this entire A with this area. So you can clearly see out of all of this, we are only getting A. हमारे पास सिर्फ A आ रहा है, so that is why it is equivalent to A only. Okay. Then you have De Morgan's law. So De Morgan's law states something like this. So if you have A plus B whole complementation, it can be written as A complement dot B complement. Or if you have A dot B whole complementation, it can be written as A complement plus B complement. So these are your De Morgan's law. So this De Morgan law is going to be very very important for you guys, because हम इस De Morgan's law को बहुत ज़्यादा extensively use करने वाले हैं. We are going to use it very very extensively. So please make note of these. So this PPT also I'm going to embed here in the description section of this video. So if you want to get this PPT, whatever I'm teaching right now, so you can also get the same PPT, you can download it from there. Then you have identity property. So here we have we have logical inverse. That means if you do 0 complement, then 0 complement is equal to 1. If you do 1 complement is equal to 0. And then you have involution. Involution means if you do double complement of any variable, you will get the same variable. Okay. So I think all of these properties you already know. आप इसके ऊपर काफ़ी जो questions हैं आपने अपनी बीटेक के दौरान आपने इन सभी को काफ़ी डिटेल में स्टडी किया होगा. Must have studied all of these concepts in a lot of detail. अब हमारे पास इन सभी ऑपरेटर्स की प्रेसिडेंस क्या है? प्रेसिडेंस मीन्स इफ इन एनी एक्सप्रेशन you are getting an AND operator, you are getting a NOT operator, you are getting an OR operator, all of these operators together, then which operation you have to do first? So first of all, you should solve the parenthesis, that is something which is in bracket. Then you should follow the NOT operator. उसके बाद आप follow करेंगे, solve करेंगे AND operator को, and in the last we are having the OR operator. This is the precedence. So I'll explain you all of these precedence one by one. I'll take a lot of examples. तो आपको example से सब कुछ clear हो जाएगा. Okay. And this is representing. Okay. Let me take an example first before I explain the De Morgan's theorem. So let me take a few examples ताकि आपको सब कुछ बहुत clear रहे. I wanted that everything whatever I'm telling you, you should be able to follow everything in a crystal clear manner. तो सब कुछ मैं बहुत अच्छे से कराऊंगा. Just follow through my lectures. You will understand everything very freely and clearly. So this is demorganize. Demorganize means just apply De Morgan's law on this. This is what I am going to do. Okay. So here what I can see here. So if you remember what is De Morgan's law. De Morgan's law say that if we have A plus B whole complement, then it is equal to A complement dot B complement. And if you have A dot B whole complement, then it is equal to A complement plus B complement. If you remember the De Morgan's law, this is the De Morgan's law. ये हमने देखा है अभी. We have seen this De Morgan's law. Now here in this expression, what you can see is you can assume this entire as X. You can assume this entire as Y. Then what is this equation? This equation says X dot Y whole complementation. That means I can apply De Morgan's law on this. So you can apply it in this manner. You can have A plus B complement whole complement dot C plus, so this dot will be changed to plus, this is plus, so C plus D complement whole complementation. And then here you will get A complement dot B complement complement plus, again here I applied De Morgan's law, and here also I'm going to apply De Morgan's law. So this is going to be C complement dot D complement complement like this. So this here it will become A complement dot B plus this here it will become C complement dot D. So that means after solving this entire expression using De Morgan's law, after simplifying this expression using De Morgan's law, this is the expression that I'm getting. तो ये जो expression है ये मेरे पास आ रही है. Okay, so I think you understood what is De Morgan's law. Let me also show you the proof of De Morgan's law. So here you can clearly see I have proved the De Morgan's theorem. तो De Morgan's theorem का है, so whenever we have A plus B whole complementation, that means we have a NOR gate. If we have A plus B whole complementation, it means we have a NOR gate. So the truth table for NOR gate is something like this. So this is the truth table for the NOR gate. So this is A, this is B, and this is the truth table. So NOR gate assumes a value 1 whenever both A and B are 0. Otherwise it assumes a value 0 in all the other cases. Now this A complement, A plus B whole complement, it can also be written as A complement dot B complement. So complement means I'm going to represent by a NOT operation, and this dot means I'm going to represent by an AND operation. तो dot का मतलब है हम उसको AND operation से represent करेंगे, और complement का मतलब है हम उसको NOT operation से represent करेंगे. That means it can also be represented in this manner, which is bubbled AND gate. So A, if you give a NOT here, so that is A complement. B, if you give a NOT here, that is B complement, and you are performing AND operation, so there is A complement dot B complement. And if you look at the truth table for this is representing A, then this is A complement. A complement means every 0 will be changed to 1, every 1 will be changed to 0. In the same way, you can also find out B complement, every 0 will be changed to 1, every 1 will be changed to 0. And then the end result here, जो आपका end result रहेगा, this end result is going to be 1 0 0. And you can clearly see this end result and this end result, they are exactly the same. दोनों का जो result है वो exactly same है. So in this manner also you can prove the De Morgan's theorem, or you can say De Morgan's law. इतना clear है सभी के साथ? I hope it is clear. Now let us do a few questions here. Let us solve a few questions. Let us try to reduce a few expressions using these laws. Then you will understand it more clearly. आपको ज़्यादा अच्छे से comfortable feel होगा. You will understand it more clearly. So the question is as follows. Reduce the expression. I want to reduce this expression. So in this expression we have 4 literals. So there is a terminology that I used. The terminology is literal. Terminology is literal. So what do you mean by literal? Literal means appearance of every variable is called as a literal. कोई भी वेरिएबल कितनी बार एक एक्सप्रेशन में अपीयर हो रहा है उसको हम बोलेंगे लिटरल. जैसे यहाँ पर वी हैव अ वेरिएबल a and we have a variable b, right? So how many times it is appearing? So every time it will be appearing, we are going to count as a literals, right? So here we have, it is 1 literal, 2, 3, 4 and 5. So in this expression there are total of 5 literals. इस पूरी expression में total 5 literals है. And what is reducing the expression? What do you really mean by reducing the expression? Reducing the expression means we want to minimize the number of appearances of literals. इस पूरी expression में हमें जितने literals show हुए हैं हमें उन literals को minimize करना है. We want to minimize the number of appearances of literals. Let us see how can we do it. So we have the following expression. We have ab whole complement plus a complement plus ab, and this is whole complementation. Correct? So in this entire expression I can apply De Morgan's law. मैं पूरी expression में De Morgan's law apply करूँगा. If I will apply De Morgan's law, then this or will change to and this and will change to or. And जो है वो or में change हो जाएगा और जो है वो and के अंदर change हो जाएगा. So if you apply De Morgan's law, then this will be looking something like this: ab complement complement dot a complement dot ab whole complement. ठीक है, क्लियर? नाउ दिस एक्सप्रेशन कैन ऑल्सो बी रिटन एज ए बी डॉट ए कॉम्प्लीमेंट डॉट ए बी होल कॉम्प्लीमेंटेशन लाइक दिस. इस पूरी एक्सप्रेशन को हम कुछ ऐसा भी लिख सकते हैं, बट इफ यू क्लियरली सी आई कैन शो यू शॉर्टकट हियर. आई कैन डू दिस इन अ शॉर्टकट मैनर. आप इसको शॉर्टकट मैनर में भी कर सकते हैं. इफ यू डू दिस इन अ शॉर्टकट मैनर देन यू विल आइडेंटिफाई देन दिस ए बी डॉट ए होल कॉम्प्लीमेंट then this is equal to 0, right? This is a shortcut manner, right? I can also solve it properly. मैं इसको properly solve कर सकता हूँ. I'll do it in both the manners, right? So here, first of all, let me show you this shortcut here. We already know that we have a dot a complement is equal to 0, and if we have a plus a complement, then it is equal to 1, right? And if you do a dot 0, then it is equal to 0. If you do a dot 1, then it is equal to 1 like this. So we already know some of these rules. You also know that if you do a plus 0, then it is equal to a, and if you do a dot 0 or a plus 1 instead of 0, let me change it to a plus 1. So if we have a plus 1, then it is equal to 1. So this is actually a, this is not 0, this is equal to a. So we already know most of these rules. आपको ये सभी rules already पता है. So just correct this one. इसको आप correct कर सकते हैं. So a dot 1 is equal to a. So in the same way, I can say that this entire is representing x. This entire is representing x. Then this one will be representing x complement. So x dot x complement is 0, right? So I can also say this equation in this manner. I can say it is a complement dot 0. That is why this entire expression can be reduced to 0. So I can minimize this entire expression with 0 literals. यहाँ पर कितने literals हो जाएंगे हमारे पास? 0 literals आएंगे. But there's one more proper expression that I can give you here. So this can be written as a dot b dot a complement. Here we have ab whole complementation. Now here you can clearly see that this dot operator is commutative. Dot operator जो है commutative है. That is why I can also write it in this manner: a dot a complement dot b, and here we have ab whole complementation. And because this dot operator is commutative, and now we have a dot a complement, this is equal to 0, right? So I can say it as a 0 dot b dot ab whole complementation. Correct? Now what is 0 dot b? 0 dot b is 0, right? And this equation will become 0 dot ab whole complementation. Even if you open this one, you can easily find out that the end result is equal to 0. Even if you apply De Morgan's law here and then even you do it, you will find out that the end result is 0. So this entire expression can be minimized to 0. हम इस पूरी expression को 0 के साथ minimize कर सकते हैं, right? I hope that you understood this one. Let us look at the next question here. So it is saying reduce expression. We have an expression. I want to reduce this expression. I want to minimize the total number of appearances of literals. How many literals are there? We have 1, 2, 3, 4, 5, 6, 7. So we have a total of 7 literals. I want to minimize the number of appearances of literals in this expression. Then only I can reduce it. How can I do it? Let us do it. So we have a in brackets. We have b plus c complementation, and here we have ab प्लस ए सी कॉम्प्लीमेंट होल कॉम्प्लीमेंट. दिस इज योर एक्सप्रेशन. ये आपकी प्रॉपर एक्सप्रेशन है. नाउ इन दिस एक्सप्रेशन यू कैन अप्लाई De Morgan's law here. आप यहाँ पर De Morgan's law अप्लाई कर सकते हैं. सो आफ्टर अप्लाइंग De Morgan's law we get a b plus c complement, and here if you apply De Morgan's law, this is basically ab complement dot ac complement whole complement. Clear? And further you can also apply De Morgan's law in this inside in another expression. आप यहाँ पर भी De Morgan's law अप्लाई कर सकते हैं. So let me apply the De Morgan's law here first. मैं यहाँ पर De Morgan's law अप्लाई करता हूँ. So I get a b plus c complement. Here we have ab whole complement dot this is a complement, right, plus c complement complement, and because we have two complements then that will be equal to c only. तो आपके पास यहाँ पर two complements हैं. Here we have two complements, so this is entirely equal to c. Then open the brackets. तो आपके पास bracket open करेंगे तो क्या मिलेगा आपको? There is a b plus c complement. This is ab whole complement a complement, right, plus this is ab whole complement c. And further again you can open these brackets. You will find out this is a b plus c complement. This is a b whole complement a complement, plus this is very interesting. So here we have a b whole complement c dot c complementation, right? Now what you will find here, you will find out that c dot c complement is actually equal to 0. So this entire expression, ये जो expression का ये जो part है, this entire part is actually equivalent to 0. ये पूरा part जो है वो 0 के equivalent हो जाएगा, right? So this part is 0. Then what can I find out here? I have a, this is b plus c complement. Further I can open these, so I can apply De Morgan's law. So this is a complement plus b complement, and here we have a complement like this. Okay, right? I can further open this one. आप इसको फिर से open कर सकते हैं. So then you will get b plus c complement a complement dot a complement plus c complement b complement dot a complementation. ठीक है? Then what is this c complement dot a complement complement? ये वैल्यू क्या होगी आपके पास? So this value is equivalent to a complement only. आप इसको सिर्फ a complement भी लिख सकते हैं. Okay, and you can open the entire bracket. आप पूरे brackets को अगर आप open करेंगे, then what will you get? You will get ab plus a complement a c complement plus a complement a b complement and c complement. Correct? Now there's something very interesting इस पूरी expression में. So a complement dot a, this entire will be 0. A complement dot a, this entire expression will be 0. So this entire expression here, it can be minimized to ab. ये जो पूरी expression है, this entire expression can be directly minimized to ab like this. So just have to apply the Boolean algebra laws. जो भी मैंने आपको laws बताए थे, आपको सिर्फ उन्हीं laws को apply करना है. Just by applying those laws, you will be able to solve this expression very easily, right? So you can clearly see it is very easy, such an easy problem. बहुत आसान problem है, बहुत easily आप इसको कर सकते हैं. So you can also see this entire expression here step by step. आप यहाँ पर पूरी expression को देख सकते हैं. So in this entire explanation, you can see what is the law that we have applied. So यहाँ पर आपने De Morgan's law apply किया. Then we have applied this law. Then here again. So what are the laws we have applied? We have simplified. जो भी laws आपने apply किए हैं, you can see this entire explanation here also. Now let us look at this one. So here in this expression, what is the number of litters? कितने litters हैं यहाँ पर? We have 1, 2, 3, 4, 5, 6, 7. So we have a total of 7 litters. And I want to minimize this expression. Let us see. So you have a plus b ac plus b plus c complement d. ठीक है? So now open these brackets. आप इसको brackets को open करेंगे. Then what will you get? You will get a plus b ac plus bd plus c complement d. Now again open this one. तो अगर आप check करेंगे, this is a plus a b c plus this is actually c. I should rub this one. Yeah. So this is abc plus b dot d plus b dot c complement d. Now again, what is this b dot d? This is equal to bd only. ये किसके equal है? ये सिर्फ bd के equal है, right? So we have a plus a b c plus bd plus b c complement d. क्लियर, इतना क्लियर है सभी के साथ? नाउ समथिंग वेरी इंटरेस्टिंग कैन बी डन हियर, कुछ इंटरेस्टिंग चीजें यहाँ पर की जा सकती है, लॉट ऑफ इंटरेस्टिंग थिंग्स आर पॉसिबल. व्हाट इज दैट इंटरेस्टिंग थिंग? वो क्या इंटरेस्टिंग है? फ्रॉम दिस एक्सप्रेशन यू कैन टेक a as common, right? So if you take a as common, this will be written as 1 plus bc, and from these two expression you can take bd as common, then this can be written as 1 plus c complementation. So 1 plus this equation is 1 and 1 plus c complement is 1. So this entire expression can be written as a plus bd. So now you can clearly see what is the number of literals here. Only 3 literals are present. इस पूरी expression में सिर्फ 3 literals ही present है. Only 3 literals are present in this case. So this is how you can reduce or simplify an expression. इस तरीके से आप इसको reduce भी कर सकते हैं और simplify भी कर सकते हैं. So you can see the same solution here. So the result of this entire expression is a plus bd. Okay, now let us do the next one. We want to minimize this expression, so let us do it. So here first of all you can apply De Morgan's law. आप यहाँ पर De Morgan's law apply करेंगे. So this will be written as a complement dot b c complement complement, and this is a b complement plus a b c. Clear? So this is double complementation, so I can just write it as bc. So I can write it as a complement bc, and this is a b complement plus a b c. Now open the brackets. So if you open the brackets you will get something like this. So here you will get a complement b c dot a b complement plus a complement b c, and we have a b c. Clear? Now here we have b dot b complement, and we have a dot a complement. So this entire expression here, this is equal to 0. And on the second part here we have b dot b. So if you know that b dot b is equal to b only, in the same way c dot c is equal to c, but this a complement dot a complement a is equal to 0. तो ये जो पूरी expression है, this expression will be 0. So that means this entire expression can be minimized to 0. इस पूरी expression को हम 0 से minimize कर सकते हैं. And it is very easy to do it. So you can also see this entire solution. You can minimize this entire expression to 0. आप इसको 0 तक minimize लेकर कर सकते हैं. Okay? I hope it is clear with all of you. Now let us take the next one here. So in this expression we have b plus bc, b plus b complement c plus bd. Okay, so before solving this, let us do something very interesting. I can take b as common here. I can distribute b. यहाँ पर मैं b को common लूँगा और यहाँ पर मैं distributive property को apply करूँगा. So that means I can use it this way. So if you take b as common, I will get 1 plus c. And here if you apply distributive property, then this is b plus b complement dot b plus c, and here we have b plus d. Clear? This one, this is equal to 1. And this is also equal to 1. So this expression can also be written in this manner. We have b dot, we have b plus c dot, we have b plus d. And further if you open it, it will be equal to b dot b plus b dot c, and here it is b plus d. So this b dot b is equal to b only. इसको हम 2 बार b लिखने की जगह पर we can also write it as single b. Again if you check it out here, I can take b as common. मैं यहाँ से b common ले लूँगा. So this is b 1 plus c plus b plus d. Right? So you can also see this is basically your absorption law. कौन सा law है यहाँ पर? This is absorption law. So this can be written as b, and this is actually dot operator. So b dot b plus d, which is equivalent to, again here also I can apply absorption law. यहाँ पर भी आप absorption law लगाएंगे. So after applying absorption law, this entire expression will be equal to b only. ये पूरी expression जो है ये b के equal होगी. Such an easy problem, बहुत ही आसान था. You can also see the solution. So this entire expression is equivalent to b. पूरी expression जो है वो b के equal है. Such an easy problem here. Okay. Let us look at this one. So here we have to show that the left hand side is equivalent to right hand side. तो जो left hand side है वो right hand side है के equal है यहाँ पर. So let me show you the solution here. So let us take the left hand side and let us try to see if it is equivalent to right hand side or not. So here we have AB. Here we have A, B complement C. Let me make it a little space. And then we have B C complement. I can take the left hand side here. Now if you look at the right hand side, अगर आप यहाँ पर right hand side को थोड़ा सा focus करके देखेंगे, if you look at the right hand side, then you will find out there is no AB. यहाँ पर कोई भी AB नहीं है. So somehow I have to find a method to eliminate this AB. Correct? Now you know a property that if you do C plus C complement, then it is equivalent to 1. Correct? So I can apply C dot C complement with this AB. अब इसको हम लोग क्या लिखेंगे? We are going to write it as AB C plus C complement plus A B complement C plus we have B C complement. And now in this case again this will be equal to ABC plus A B C complement. This is A B complement C plus B C complement. आप इसको कुछ ऐसे लिख सकते हैं. Clear? I hope this much is clear. इतना आप सभी के साथ clear होगा. Now look at it very carefully. What I'm going to do here is I'm going to take this expression, I'm going to take this one, and I can take BC complement as common. In the same way, I'm going to take this one and I'm going to take this one, and from these two I can take AC as common. So if I take AC as common, then here I will get B plus B complement, and here if I take BC complement as common, then I will get A plus 1. So this is equivalent to 1 and this is equivalent to 1. So this entire expression is equal to AC plus BC complement. So that means the left hand side is equivalent to the right hand side. Such an easy problem to prove. बहुत easy तरीके से आपने इसको prove कर दिया. So you can also see the same expression here. आप यहाँ पर भी same expression को देख सकते हैं. Okay. So let us solve this one. इसको solve करने की कोशिश करते हैं. So we have to show that the left hand side is equivalent to the right hand side. So you can see on the right hand side we have only B and we have only C. आपके पास सिर्फ B और C है और हमारे पास वहाँ पर कुछ भी नहीं है. ठीक है. So let us try to identify कि हम इसको कैसे minimize कर सकते हैं. So in this case here we have B, here also we have B, and here also we have B. Here we have AC and here also A complement C is there. So from these three I can take B as common and from here I can take C as common. तो आपके पास क्या मिलेगा यहाँ पर? So you are going to get, if I take B as common, I will get 1 plus BD complement plus here I will get A D complement, and from here these two I can take C as common, then I will get A B complement plus A complement. आपके पास कुछ ऐसा मिलेगा. So if you add 1 with any expression, then that expression becomes 1. So this is B, right? Plus, and here you can distribute A complement. अब यहाँ पर A complement को distribute करेंगे. So if you distribute A complement, then this is equivalent to A plus A complementation, and this is B complement plus A complement, and this is equivalent to 1. So this entire expression can also be written as B plus C A complement plus B complement. So now I can take it as B plus this is A complement C plus B complement C. Okay. Now from here I can take this B and I can distribute it over this expression. आप इस B को उसके साथ distribute कर सकते हैं. So if you distribute it, what will you get? आपको क्या मिलेगा यहाँ पर? Let me show it here. So we have B plus B complement dot B plus C dot you have this expression. Sorry, you have this expression which is A complement C. Now here this is equivalent to 1. ये 1 के equal है, so I can write it as B plus C plus A complement C, and I can apply absorption law here. So this is B plus C. ये पूरी जो expression है वो B plus C के equal है. So in this way you can prove that left hand side is equal to the right hand side. Such an easy problem. बस आपको पता होना चाहिए what is the right expression you have to apply. So this is how you can easily prove it that this is equivalent to B plus C. आप इसको इस तरीके से B plus C के equivalent prove कर सकते हैं. Okay. Let us look at the principle of duality. So what does this principle of duality says? It says in any expression, in any of the Boolean expressions, I can keep all the variables as it is. Wherever we have a 0, I can convert this 0 to 1. Wherever we have a 1, I can convert this 1 to 0. Wherever we have this OR operation, I can convert the OR operation to AND operation, and I can convert AND operation to OR operations. Then the resultant equation will also be valid. Let me explain what I'm trying to say. So if we have any equation, I can say, let us suppose the equation is A plus BC This is their equation, right? And I'm representing this equation by a function f. So I can find out a dual form of this equation. So I can find out a dual form. Let us suppose I'm representing the dual form by fd. So what is the dual form? In your dual form, wherever you have a plus operator, I'm going to convert this plus operator to dot, and wherever you have a dot operator, I'm going to convert this dot operator to plus. So if this equation satisfies something, then this equation will also satisfy that. Let me write the dual form here. So what is the dual form of this expression? So here dual form is a dot b plus c. This is the dual form expression. तो ये आपकी dual form है. Okay. In the same way, let us assume that we have De Morgan's law. We have De Morgan's law. So what does this De Morgan's law say? It says if we have a plus b, or let me say, because it is a variable, so let me write it as capital A. So if you have capital A plus capital B whole complementation, then it is equal to A complement dot B complement. This is what De Morgan's law say. So I can find the dual expression for this. So what will be the dual expression here? Dual expression क्या होगी? So in the dual expression, I'm going to convert this plus to dot. I'm going to convert this dot to plus. So that means here, if I have A dot B whole complementation, then in this case we have A complement plus B complement. So if this equation is valid, अगर ये वाली equation valid है, therefore the dual form, the dual of this equation will also be valid. इस equation की जो dual form है, वो भी valid रहेगी. Okay. The same you can see here. So I've taken a list of the dual form of every lot of equations, right? So here you can see this is your first equation. Here we have 0 complement is equal to 1. So this equation satisfies, right? So we already know if you take a complement of 0, you will get a 1. So what is the dual form of this equation? You have to convert this 0 to 1 and you have to convert this 1 to 0. Then this is your dual form. So this dual form is also valid. So take any random equation whatsoever. इसमें से कोई भी random equation लो. Let us assume I am taking this equation. So in this equation, I have to convert this dot to plus. I have to convert this 1 to 0. Then the dual form is also valid. So this dot to plus and 1 to 0. So this equation is also valid. So as you can see here, the dual form of each of these expressions, duality also holds. Now let us look at some little more complicated expressions here. If you check out, maybe you can take, so you can start with this expression. So in this expression we have dot operator. So here a dot b is equal to b dot a. So that is your commutative law. So in your commutative law, if you change this dot to plus, then the resultant equation will also be valid. So here a dot b is equal to b dot a. So if you change it, it will be a plus b is equal to b plus a. So a plus b is equal to b plus a will also be valid. Next, check out this equation. So here a dot b plus c is equal to ab plus ac. So here this dot will be changed to plus and this plus will be changed to dot. So this equation will be a plus b dot c, and here this dot will be changed to plus, this plus will be changed to dot. So it will be equal to a plus b dot a plus c. Take another equation here randomly. Let me take the equation number 15th. So here a plus b dot a complement plus c dot b plus c, and here a plus b dot a complement plus c. So change all of these plus to dots. इन सभी plus को dot में change करो and change all of these dots to plus. Then the equation we will get is ab plus a complement c plus bc. It is equivalent to ab plus a complement c. So this is how you can find out the dual form of this expression. Let me take some more examples, some more complicated examples. See, you can take these examples and you can even prove this right hand side. आप इस side को भी prove कर सकते हैं. Let us take this example here. तो इस example को अगर आप check करेंगे, so this is a very complicated equations. Why? Because here there are a lot of variables are involved. Plus the expression is also very complicated, very complex. So I have to convert this dot to plus, this dot to plus, this dot to plus, and this plus to dot. This plus to dot, this dot to plus, this plus to dot, this dot to plus. And then this 0 will be changed to 1. ये जो 0 है ये आपका 1 में change हो जाएगा. Then the resultant equation you will get is, this is your resultant equation, and here I've changed that 0 to 1. So in this manner, any of these expressions, ये सभी जो expressions है which are represented in a which are present here, if these expressions are valid, therefore the dual form are also valid. In these dual forms, this is actually equivalent to this. Dual forms actually hold. So in this manner you can find the dual forms of each of these equations. Okay. The next one is your consensus theorem. So what does this consensus theorem says? It says if you have AB plus A complement C plus BC, it is equivalent to AB plus A complement C. How can I prove it? कैसे इसको prove किया जा सकता है? Proving it is very very easy. So here we have AB, right? So I have AB plus A complement C plus here BC. So with this BC, I'm going to add A complement again. See, first of all, you have to see what are the things you want, right? So I want to have A complement C. मुझे यहाँ पर A complement C चाहिए. I want to have this A complement C. So what I can do here is I can add A plus A complementation here. मैं यहाँ पर A plus A complementation को add कर सकता हूँ. Then what I will get? I will get AB plus A complement C plus ABC plus A complement BC. ठीक है? So in this entire expression, right? This is ABC, right? I think I missed it. So this is ABC. So in this entire expression, from here you can take AB as common. इन दोनों से आप AB को common ले सकते हैं. From here you can take A complement C as common. Then your equation will be, if I take AB as common, this is 1 plus C, and if I take A complement C as common, this is 1 plus B. So in this case, again this equation will be equal to 1. This equation will also be equal to 1. So this entire equation is AB plus A complement C, which is equivalent to your right hand side, जो कि आपके right hand side के equivalent है. So I can really prove this consensus theorem. So this consensus theorem is very useful in solving lot of problems. इस काफ़ी क्वेश्चंस को सॉल्व करने के लिए जो कंसेंसस थ्योरम है काफ़ी काम आती है. एंड यू कैन सी दिस एंटायर डेरिवेशन प्रोसेस, पूरी डेरिवेशन प्रोसेस को आप प्रॉपरली देख सकते हैं. आई हैव आल्सो इंक्लूडेड दिस एंटायर डेरिवेशन प्रोसेस हियर. ओके, एंड देन अगेन दिस इज एक्सटेंडेड वर्जन ऑफ कंसेंसस थ्योरम. आप कंसेंसस थ्योरम को एक्सटेंड भी कर सकते हैं. इट कैन बी एक्सटेंडेड फॉर 4 variables, right? It can be extended for 5 variables and so on. So right now here you can see this extended version of consensus theorem with 4 variables. But really we do not need this in the examination, because obviously you are not going to remember such a complex theorem, but rather you can just solve and prove this in the exam. So whenever that is required, you can easily prove it. So that is why you don't have to really remember them. Okay. So this is your second theorem here. So this theorem is basically the duality of consensus theorem. If you remember, what was your consensus theorem? So your consensus theorem was AB plus A complement C plus BC, then it is equivalent to AB plus A complement C. This was your consensus theorem. So this theorem here, it is just a dual form of consensus theorem. ये बस उसकी dual form है. So obviously if the consensus theorem is valid, therefore this will also be valid, and you can also prove it. आप इसको prove कर सकते हैं easily. Okay, so this is the entire derivation process. You can view it, you can pause the video and you can view the entire derivation process. I hope this is very easy. काफ़ी आसान है. आप इसको वीडियो को pause करके इसको देख सकते हैं. The next theorem is your transposition theorem. ये आपकी transposition theorem है. So in your transposition theorem you have AB plus A complement C. It can be written as A plus C dot A complement plus B. हम इसको A plus C dot A complement plus B भी लिख सकते हैं. So obviously proving it is very very easy. So just like I proved the consensus theorem, the same way I can also prove this entire expression. So I can take the right hand side simply. Just take the right hand side as it is, and in this right hand side I can just open the brackets. So I will get these expressions. I will get A complement, C A complement, AB and CB. So this will become 0. So I will get A complement C plus AB plus BC. And from here, what you can do is with this BC, you can add A plus A complementation. And then once you open the brackets again, you can take something as common. So पूरी expression में से from these two I can take AB as common, and from these two I can take A complement C as common, and then you will get AB plus A complementation C. It is very easy. Proving the transposition theorem is also very very easy again. So now let us see this problem here. So we are just trying to identify what is the number of functions possible with 2 variables. So as I said here, you can say we have 2 variables. We have a variable x and we have a variable y. So with these two variables, they can take approximately 2 raised to power 2 values. We have already seen it. कितनी वैल्यू ले सकते हैं हमारे पास ये? It can take 2 raised to power 2 values, which is equal to 4. It can have 4 such values. Now how many number of functions are possible with two variables? यहाँ पर कितने functions possible है? So what is a function? What is this function? So this function represents an equation which is a Boolean expression, right? So जैसे for example here, this function number 0 is representing 0. This function number 1 is representing a dot b, right? So a dot b. So जो भी आपकी Boolean expression है, you can represent a Boolean expression with the help of a function. So this function number 1 is representing an AND operation. This function number 2 here, function number 2 is representing your operation which is a dot b complementation. This function number 3 is representing your x, or you can say clearly a. So if I just name it as a, if I just name it as b, अगर मैं x को a बोलूँगा और y को b बोलूँगा, then you can see this function number 3 is representing your a. Now this function number 4 here, this function number 4 is representing your a complement b. So in this manner, if you check it out how many such functions are possible, so with the help of two variables there are total of 16 functions are possible. कितने functions possible है हमारे पास? 16 functions possible है. But what about only one variable? If you have only one variable, let us suppose you have a variable a, right? So with this variable a can take two values. It can take a value 0, it can take a value 1. So on this variable a, how many functions are possible? We can have a function 0 which is equal to 0 0, then we can have a function 1 which is equal to 0 1, then we can have a function 2 which is equal to 1 0, then we can have a function 3 which is equal to 1 1. So with only one variable there are 4 unique functions are possible. यहाँ पर 4 functions possible हैं. So this function number 0 is representing 0, this function number 1 is representing a, this function number 2 is representing a complementation, and this function number 3 is representing only 1, right? So in this way, so there are 4 such functions are possible. Now my question here is, if we have n variables, then how many functions are possible? Let me explain you. So here this is representing the number of variables, and here it is representing the number of functions, okay? So if the number of variables that we have, if number of variable is only 1, then number of functions possible are 4. If the number of variables are 2, number of functions possible are 16. So as you can see, there are total of 16 functions. If the number of variables are 3, then there are total of 64 functions which are possible. ठीक है, so यहाँ पर let me again check. So I think it is not 64. ये 64 नहीं होना चाहिए. This is 256 functions are possible. 256 functions are possible. The same way, if the number of variables are n, then how many such functions are possible? So value is very easy. It is 2 raised to power 2 raised to power n. कितने functions possible है यहाँ पर? 2 raised to power 2 raised to power n. Okay, let me again write it here. Number of functions possible is 2 raised to power 2 raised to power n. इतने functions आपके पास possible हैं. How I calculated this value? So calculating this value is very easy. So you can see if the number of variables are n, अगर आपके पास total n variables हैं, then with those n variables, how many combinations are possible? 2 raised to power n combinations are possible. अब ये जो 2 raised to power n combination है, so it can assume various different values, correct? जैसे for this combination we have two values, either it can take a value 0 or it can take a value 1. For this combination we have two values, either it can take a value 0 or it can take a value 1. For this combination we have two values, it can take a value 0, it can take a value 1. For this combination again we have two values, it can take a value 0 or it can take a value 1, right? तो हर एक के केस में हमारे पास दो अलग अलग combinations possible है. So if you multiply all of them, so this will be equal to 2 raised to power 4, or roughly you can say it is 2 raised to power 2 raised to power 2, right? So because there are two variables here. So in this manner you can calculate how many such functions are possible for the given number of variables. Just say for example, if we have the number of variables as 3, so with these 3 variables 2 raised to power 2 raised to power 3 functions are possible, which is 2 raised to power 8, and 2 raised to power 8 is 256. तो आपके पास 256 जो है उतने functions यहाँ पर possible होंगे. Okay, So as you can see, I've named all of these functions one by one. So this is representing the function number 0. So function number 0 is called as a null function because this is representing 0. Then function number 1 is representing your AND operation. Function number 2, which is x y complement, this is representing your inhibition operation. So that means x but not y. Then you have function number 3. Function number 3 is representing your transfer operation. So whatever x you are going to have, just transfer it to the output. Then function number 4 is again representing your inhibition operation, which is x complement y. Function number 5 is representing your transfer operation. Function number 6 is representing your exclusive OR, that is x y complement plus x complement y. Function number 7 is representing your OR operation, which is x plus y. In the same way, you can see function number 8 is represented as a NOR gate. Function number 9 is representing an equivalence, or you can say an exclusive NOR. So this is x y plus x complement y complement. So this exclusive NOR is also called as equivalence. Then function number 10 is representing your complementation operation, which is y complement. Function number 11 is implication, right? So that is x plus y complement. Function number 12 is again x complementation, which is again a complementation operation. Function number 13 is implication, which is x complement plus y. Function number 14 is your NAND operation, and function number 15 is your identity operation, which is F15. So in this manner, you can see with the help of two variables, there are 16 functions are possible, and we can name all of these unique functions. So these names are not that much important. Some of these names obviously you already know, but you do not have to remember all of these values. The only thing that is important here is to calculate what is the number of functions are possible, because in previous gate question they have asked this question. In previous year gate examination they have asked this question many times, that given n variables, how many functions are possible with n variables. Okay, again don't worry, we are going to see a lot of example based on this. काफी example हमारे पास आने वाले हैं. Okay, so this is the table that you can see. If we have only one variable, with one variables there are two combinations are possible. So number of functions are 2 raised to power 1. Okay, so which is equal to 4 functions. With two variables there are 4 combinations are possible, and number of functions are 2 raised to power 2. With 3 variables, number of combinations are 2 raised to power 3, and number of functions are 2 raised to power 3. With 4 variables, number of combinations are 2 raised to power 4, and number of functions are 2 raised to power 4. With n variables, number of combinations are 2 raised to power n, and number of possible functions are 2 raised to power n. So these are the values that you should remember. ये values आपको पता होनी चाहिए, because they have asked a lot of previous year questions based on just these values. इन्हीं values के ऊपर उन्हें काफ़ी previous year questions के बारे में पूछा है. Okay, I hope this much is clear. So in the next video, let us look at the canonical forms. What is canonical sum of product and what is canonical product of sum. So far we have seen the properties of AND gate and OR gate. I told you that both AND gate and OR gate both are commutative as well as associative. In this session, let us look at the NAND gate and NOR gate. You know what is a NAND gate. NAND gate is AND gate plus a NOT operator. What is a NOR gate? NOR gate is a OR gate plus a NOT operator. So both of these, NAND gate and NOR gate, both of them are commutative, but they are not associative. ये दोनों जो ऑपरेटर्स हैं, ये जो दोनों गेट हैं, ये आपके कॉम्बिनेटिव हैं, लेकिन ये एसोसिएटिव नहीं है. Let me explain you with the help of an example. So first of all, we will take your NAND gate. ठीक है? Let us take the NAND gate. So you know what is the symbol of NAND gate? NAND gate is something like this, that we are going to take a AND gate here, and with this AND gate I'm going to use a dot operator to make it a NAND. Right? So if the input is A here and the input is B here, then the output will be A dot B whole complementation. So I told you that NAND gate are commutative. Commutative means A NAND B. So NAND sign is this. A NAND B is equal to B NAND A. तो ये जो साइन है आपके पास एरो का, this is the sign of NAND. At the same time, we can also have a similar sign for NOR. So when I'm saying they are not associative, it means that A NAND B NAND C, this is not equal to A NAND B NAND C. तो ये जो दोनों हैं ये equal to नहीं है. Let me prove it. So because okay, so here let us take the left hand side here. So what is this left hand side? Left hand side says we have A NAND, B NAND, C. So let us convert this gate with the help of an AND gate and the OR gate. So this will become A dot B complement dot C whole complementation. And you can apply De Morgan's law on this. If you apply De Morgan's law, it will be A dot B complement complement plus C complement, which is equal to AB plus C complementation. जो किसके इक्वल है? AB plus C complement के इक्वल है. In the same way, I can take the right hand side. I can take the right hand side. So what is the right hand side? Right hand side says it is A NAND, B NAND, C. So again, if you apply the De Morgan's law, let us first convert it to AND gate. So A and B and C complement whole complement. So again, you can apply De Morgan's law on this. If you apply De Morgan's law, this is A complement plus B dot C complement complement, which is equal to A complement plus BC, जो आपका A complement plus BC के equal है. And you can clearly see here that left hand side is not equal to the right hand side. यहाँ पर जो left hand side है वो right hand side के equal नहीं है. That is why I can clearly say that NAND gate is not associative. जो NAND gate है वो associative नहीं है. I hope you understood this one. Let us also prove the same with the NOR gate. So what is this NOR gate? NOR gate क्या होता है? What is this NOR gate? So NOR gate is a NOT gate plus an OR gate. The symbol is something like this, that I'm going to use an OR gate here, and with this OR gate I'm going to use a NOT gate. So if the input here is A, if the input here is B, then this A NOR B is actually equivalent to A plus B whole complementation. So if I say that it is not associative, what it really means is if I do A NOR B NOR C, then this is not equal to A NOR B NOR C. ये दोनों same नहीं है. Let me prove it. So I can take the left hand side here. So the left hand side is something like this, that we are going to have A plus B whole complement plus C whole complement, because I have to convert this in the help of with the help of a OR gate. Then this will become you can apply De Morgan's law. So this is A plus B complement complement dot C complement, which is equal to A plus B dot C complementation. This is the left hand side. In the same way, let us take the right hand side here. So the right hand side is A plus B plus C complement complement, right? So again apply De Morgan's law. This is A complement dot B plus C complement complement, which is equal to A complement dot B plus C. Okay, so just by looking at this, you can see the left hand side is not equal to the right hand side. So you can clearly say that your NOR gate is also not associative. आपका जो NOR gate है वो भी associative नहीं है. So these properties you should remember. Why it is important to know these properties? Because in your gate examination they ask lot of questions based on these properties. इस properties के ऊपर वो काफ़ी questions पूछते हैं. So you should know what are these properties. Okay, I hope this is useful. Let us look at the next topic. We can represent every Boolean expression with the help of a function. Just like you can see, this is a Boolean expression which is A complement B plus B complement C. I can represent this Boolean expression with the function f of A, B, C. We have already seen this, but can we make a truth table for this? क्या हम इसके लिए truth table बना सकते हैं? Let me show you this. So here in this case, we have three variables. The variables are A, B and C. I'm going to write A, B and C here. And because all of these A, B, C, right? So these are three variables. So how many combinations are possible here? Total 8 combinations are possible. कौन-कौन से हैं? The combinations are 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0 and 1, 1, 1. And this is the function f of A, B and C. Now what are the places where this function is assuming a value 1? Look at this expression. So this expression here, this is called as a product term. इसको हम क्या बोलते हैं यहाँ पर, दिस इज कॉल्ड एज ए प्रोडक्ट टर्म. So what is this product term? This product term says that we have A complement dot B. A complement dot B. What does it really mean? इसका मतलब क्या? What does it really mean? It means that wherever we have A complement dot B, in those locations, this product term will be assuming a value 1. उन सभी लोकेशन पे ये जो product term है इसकी value 1 होगी. Okay? And what are these combinations represent? Let me explain you what are these combinations represent. This combination represents A complement, B complement, C complement. This is A complement, B complement, C. This is A complement, B, C complement. This is A complement, B, C. This one is A, B complement, C complement. This is A, B complement, C. This is A, B, C complementation, and this one is A, B, C. So these are the terms. Now when I'm saying that this term is assuming a value 1 whenever we have A complement and B, then I can also show this in the help of a truth table. So here you can clearly see we have A complement B, and here also we have A complement B. That means these two combinations. So here with both of these two combinations, this function is assuming a value 1. तो जो function है यहाँ पर दोनों combinations पे इसकी value 1 है. At the same time, whenever we have B complement C, this is B complement C. So what are the locations where we have B complement C? यहाँ पर B complement C कहाँ पर है? So this is B complement C as well as this is B complement C. That means this combination here and this combination. So here wherever we have B complement C, so it is also assuming a value 1 here. It is also assuming a value 1 here. Okay, and in rest of the locations it is taking a value 0. यहाँ पर वैल्यू 0 है, यहाँ पर वैल्यू 0 है, यहाँ पर वैल्यू 0 है और यहाँ पर वैल्यू 0 है. So in all of these cases, in 4 locations it is assuming a value 0. In 4 locations it is assuming a value 1. So in this manner you can represent a function with the help of a truth table. Now in this truth table, if you look at each of these combinations, now each of these combination is also associated with a decimal value. जैसे आपका जो combination है it is 000. So 000 is associated with the decimal value 0. 001 it is associated with the decimal value 1. So how am I doing it? I am doing it like 001. It is in base 2. If you convert this number to a decimal number, then it is having a value 1. So 010 it is having a decimal value 2. 011 decimal value 3. 100 decimal value 4. 101 decimal value 5, 110 decimal value 6, 111 decimal value 7. So those who are studying it after a very long time, let me explain you how can you convert it. So whenever we have 110 with base 2, how can you convert it to decimal values? What you do is you take this 0 and multiply it with 2 raised power 0 plus you take this one multiply it with 2 raised power 1 plus you take this one multiply it with 2 raised power 2. So which is equal to 4 plus 2, that is equal to 6. So that is why it is having a decimal value 6. Okay, let me show you the same with the help of the truth table. So here you can clearly see that these are the combinations of ABC. These are all the possible combinations that we have seen, and these are the decimal values that each of these combinations is representing. And here these are the values of the function. So this function is assuming a value 1 whenever we have A complement B. So A complement B is this case, and it is having a value 1 whenever we have B complement C. So this is representing a B complement C, and here also we have B complement C. So in all these cases it is having a value 1, otherwise it is having a value 0. Okay, I hope it is clear. Now in these expressions there is something very important to notice. We have two kinds of term. One is your sum of product, and second one is your product of sum. Okay, so for example, if you have an expression where we have A complement B plus B complement C. So this expression is representing a sum of product expression. Why we call it as a sum of product? Then because this term is a product term. ये कौन सी term है आपके पास? Product term. This is a product term. And if you look at this term, it is also a product term. ये भी एक product term है. And then you are doing a sum of two product term. आप दो product term का sum कर रहे हैं. That is why it is called as a sum of product. In the same way, when we do product of sum, that means let us suppose if we have the expression which is a complement plus b dot b complement plus c. This is the expression. Now in this expression, this is the product term and this is the product and this is the sum term. तो अगर आप इस expression को देखेंगे, if you look at this part here, so this is representing a sum term. ये किसको represent कर रही है? एक sum term को. In the same way, this is also representing a sum term. ये भी एक sum term को represent कर रही है. So that is why it is product of sum and the first one is sum of product. Okay. Now as you can see here, we have taken these examples. So in the first function we have a, b, c, d, we have 4 variables. So in this case you can clearly see this is representing your product operation and this is representing your sum operation. So this entire expression is your sum, this entire expression is your sum, and this entire expression is your sum. And what you are doing product of sum. So this is product of sum expression. In the same way, when you do sum of product, जब आप sum of product की बात करते हैं, so this is a product term, this is a product term, this is also a product term, and you are doing sum of some product term. That is why it is called as sum of product. Okay. And what is a literal? So literal is every occurrence of a variable is called as a literal. So in this case, how many variables, how many occurrence of variables are there? 1, 2, 3, 4, 5, 6, 7. So in this case, we have a total of 7 literals. कितने literals है आपके पास? Total 7 literals है. And in this case, how many literals are there? There are a total of 6 literals. यहाँ पर आपके पास 6 literals हैं. Okay. So I think it is clear what is sum of product and what is product of sum. Now there's something called as canonical form, or you can say standard form, right? So this is canonical form, or you can say standard form. Let me explain you what do you mean by canonical form or a standard form. So this function here, it is a 3 variable function. कैसा function है? ये 3 variable का function. It is a 3 variable function. So in a 3 variable function, in every product term, if we have all the 3 variables in complemented or uncomplemented form, then we call it as a canonical sum of product. Let me explain. जितनी भी आपकी product term है यहाँ पर, जितनी भी आपकी product term है, हर एक product term के अंदर तीनों जो variables है वो या तो complemented form में हो या फिर non complemented form में हो, किसी भी form में हो, then we call this as a canonical sum of product. In the same way, in the canonical product of sum, this variable, this function is a 3 variable function. So all of these 3 variables should occur here in each of these sum terms. यहाँ पर this is the dot operator. So in each of these sum terms, all of these 3 variables should occur. यानी कि जब हम canonical sum of product की बात करते हैं, canonical sum of product, it means that in all the product term, all the variables which are present in the function, all of them should come, right? And this in canonical product of sum, in all the sum terms, all the variables which are present in the function, all of these variables should come, then we call it as a canonical form, right? Let me explain you with a few more examples, then we can look at the definitions. So here this is giving us an expression, and this expression is sum of product expression. This is an SOP expression. Why it is an SOP expression? Because it is a product term, it is a product term, and it is also a product term. But this is not representing your standard or canonical SOP. Why? Because in this product term B is missing. क्या missing है यहाँ से? B missing है. In this product term C is missing, and in this product term A is missing. So these are the variables which are missing. So we have to include these variables in this product term to make it canonical. So how can I convert it to canonical? So the current expression that we have is AC plus AB plus BC, right? Now I'm going to add here the variable B. I can say it is A, C, B plus B complement. Here the variable C is missing, so it is A, B, C plus C complement, and here the variable A is missing, so it is BC, A plus A complement. Okay. Now in this case, so this is ABC plus A, B complement C, plus this is ABC plus A, B, C complement, plus this is ABC plus A complement BC. Now here you can clearly see this term is repeated 3 times. ये जो term है ये 3 बार repeat करे. So because it is repeated 3 times, so I just have to write it once. So I can write it as A B C plus A B complement C plus A B C complement plus A complement BC. Clear? Is it clear? Right? So here all of these terms are representing your canonical sum of product. ये क्या represent कर रहे हैं यहाँ पर? Canonical sum of product. Now there's something more which is very important to notice here. So we have all of A, B, C. These three are in uncomplemented form. So I can write this as 1, 1 and 1. Here A, B complement C, all of them are here. So A is uncomplemented, B is complemented and C is uncomplemented. Here we have A, B, C complement. So I can write it as 1, 1, 0. Here A complement BC I can write as 0, 1, 1. So that means this is representing decimal number 7. This is representing decimal number 5. This is representing decimal number 6. And this is representing decimal number 3. So there's one more way in which you can represent the same function. एक और तरीके से आप इस फंक्शन को रिप्रेजेंट कर सकते हैं. How can you represent the same function? I can write it as f of a, b, c is equal to summation 3, 5, 6, 7. I've written 3, 5, 6, 7. That's it. And why I'm taking summation? Summation means we are doing a sum. Summation means a sum. We are doing a sum between these terms. So in this way also you can represent your sum of product expression. Okay? Now here this term which is a product term, it is also called as min term. ये जो product term है हम इसको min term भी बोलते हैं. So this is representing a min term, this is representing a min term and this is representing a min term. तो ये सभी जो आपकी product term है, all of these product terms are also called as min terms. ये सबको हम min terms भी बोलते हैं. Okay. Now let us take the next example here. So in this function f of a, b, c, we have a plus abc. Now we have to convert this function in a canonical form. कैसे convert करेंगे? So here b and c are missing. Right here all of them are already present. So I can add this a with bc. So I can add b plus b complement and c plus c complement, and then I'm going to have abc here. Now from this I will get AB plus AB complement, right? Here this is C plus C complement plus ABC. It can be written as ABC plus ABC complement, AB complement C plus AB complement C complement plus ABC, right? So in this entire expression ABC is present here, as well as ABC is also present here. So I can write it as ABC plus ABC complement plus AB complement C plus AB complement C complement. Correct? So if you look at each of these min terms here, so this min term is representing 1, 1, 1. This is representing 1, 1, 0. This is representing 1, 0, 1. This is representing 1, 0, 0. So this is a value 7. This is the value 6, this is the value 5, and this is the value 4. So I can also write the same function in this manner. I can also write it as summation 4, 5, 6, 7, and this is representing the function f of a, b, c. तो हम इसको इस तरीके से भी लिख सकते हैं. I hope it is clear. आप सभी को समझ में आया होगा. If you have any doubt, please feel free to ask your doubts in the comment section. Now this is representing a product of sum. So you can clearly see this is a product of sum expression, this is a product of sum expression, and this is a product of sum expression. And these product of sum expressions, these are called as your max terms. हम इनको क्या बोलते हैं? हम बोलते हैं इनको max terms. ठीक है? So how can I convert these max terms to the canonical form? कैसे convert कर सकते हैं? So I can take a, b, and what is missing here? So I can write c dot c complement. Here we have b plus c. What is missing here? A dot a complement, right? Here we have ac. So we have a plus c. What is missing here? B dot b complement, right? And then you can apply distributive law. आप यहाँ पर distributivity property को follow कर सकते हैं. You can apply distributive law here. So this will become a plus b plus c dot a plus b plus c complement dot. This is a plus b plus c dot a complement plus b plus c dot. Then we have a plus b plus C dot A plus B complement plus C. So further this and these expressions are same, so I can write it as A plus B plus C. Then we have A plus B plus C complement. Then we have A complement plus B plus C, and then we have A plus B complement plus C. So now you can see this entire product of sum is in canonical form. तो ये जो पूरा product of sum है ये canonical form में है. This is representing a canonical form. Okay. So now you can see something very interesting here. कुछ चीजें हैं जो बहुत ज़्यादा interesting है यहाँ पर. So when we take a minterm means we are discussing about the product term. When we take a maxterm, so maxterm means we are discussing about the sum term. Okay. So a minterm takes a value 1 for exactly one combination of variables. जैसे this is a minterm which is A complement B complement C complement. So if I give A as 0, if I give B as 0, if I give C as 0, then only this minterm will be having a value 1, otherwise it will be having a value 0, right? It will take a value 1 for exactly one combination of variables, right? For exactly one input combinations here. You can write it down because this point is very important. But when I take a maxterm, so this maxterm will take a value 0 for exactly one combination of variables. So here we are talking about it is taking a value 1, and here we are talking about it is taking a value 0, right? So what do I mean to say by this is, so if I write A complement, B complement, C complement, it will take a value 1 only if A is 0, B is 0 and C is 0. And this will take a value 1, so this will take a value 0 only if A is 0, B is 0 and C is 0. So in case of these maxterms, we are talking about when can these maxterms take a value 0, and here we are talking about when can take a value 1. So here you can see in these variables we have 0, 0, 1. So that means minterms will become A complement, B complement, C. But what will be the maxterm? Maxterm will be A plus B plus C complement. Here the minterm will be A complement, B, C complement. Here the maxterm will be A, B complement, C complement. So in rough words you can say whenever I have to make a minterm, in case of minterm I write 0 as A complement, I write 1 as non-complemented form. But in case of a maxterm, I write 0 as non-complement and I write 1 as a complemented form. तो ये आपको पता होना चाहिए. This should be very very clear, and we are going to take a lot of example based on this. काफी examples आएंगे. Based on those examples you can also see how can we solve it. Okay, so just again I'm repeating the same sentence again. A maxterm will assume a value 0 for exactly one input combination of variables, and minterm will assume a value 1 for exactly one combination of these input variables. ठीक है, तो ये आपको clear होना चाहिए. I think this is clear. So let us move forward. So here you can see these minterms, we represent them with the help of summation because it is the sum terms, and these max terms because they are the product terms, so that is why we represent with the help of pi. So pi represents product, summation represents sum. So in this manner, so here you can clearly see this is representing value 0, 0, 1, this is 0, 1, 1, this is 1, 1, 0. So if we convert 0, 0, 1, this is representing a value 1, 0, 1, 1 is representing a value 3, 1, 1, 0 is representing a value 6, right? So I can write it as summation 1, 3, 6, and here it is representing a value 0, this is representing a value 3, this is representing a value 6, this is representing a value 1, so I can write it as summation 0, 1, 3, 6, this is pi 1, 3, 6. तो यहाँ पर हम लोग क्या use करना है? We are going to use pi, and here we are going to use summation. So pi is used in case of product of sum, and summation is used in case of sum of product. जो product of sum में हम pi use करते हैं और जो sum of product में हम summation को use करते हैं. So this is should be clear because these terminologies we are going to use extensively while solving the questions in your examination. Most of the time they will give you these terminologies only while asking the questions. Okay, so let us take this example. Here we have a function which is A plus B complement C, and we have to represent this in the sum of minterms. हमें इसको sum of minterms में represent करना है. How can I do it? So here with this A, B plus B complement is missing, C plus C complement is missing, and here A is missing, so I'm going to do A plus A complement, and then I can expand it. After expanding it, I will get this expression, and further this expression, this is representing your, because these are minterms, so it is representing 0, sorry, it is this one is representing 1, this is representing 1, this is representing 1 because they are min terms, they are not max terms, right? So this is representing value 7. Here this is representing a value 0, 0 and 1, which is representing a value 1, right? So so this entire function here, I can also represent this entire function using this terminology. अब पूरे फंक्शन को कुछ इस तरीके से भी रिप्रेजेंट कर सकते हैं. Hello everyone. In the previous video, we have seen an introduction to Boolean algebra, and we have seen how can you minimize the Boolean expressions using the identities of Boolean algebra. हम Boolean expressions को किस तरीके से minimize कर सकते हैं using the identities, वो हम पिछले वीडियो में, पिछले सेशन में हम ऑलरेडी देख चुके हैं. Now in this session, we are going to discuss about the minimization of Boolean expressions using K-maps. Why do we need K-maps? This is the first question that you need to answer. So sometimes if you have big expressions, so minimizing those big expression takes a lot of time. Plus there are huge chances, there are very high chances that minimization of Boolean expression, during that minimization you are going to make mistakes. So that is why we are using these K-maps. With the help of K-maps, it will be very easy for us to minimize an expression. K-maps की help से किसी expression को minimize करना हमारे लिए बहुत easy हो जाएगा. It will be very easy for all of us. So this topic will approximately take us 4 to 5 hours to complete, because there are a lot of examples that we need to take. It is important for us to cover all of these examples. If we will not cover examples, then the topic will not be very clear. So we will do the following things today. First of all, we are going to look at an introduction. So that is the introduction to the K-map. What is the basic structure of K-map? How can you make a K-map for any expression? I'm going to take everything step by step. Even if in some point, if you feel that I'm using a lot of presentations, a lot of PPTs, don't worry about it. Just follow through the lectures. You will understand everything step by step. देखो काफ़ी बार ऐसा होता है, we Indians, we are not designed to study using PPTs or presentations. We are trained to study on a whiteboard or on a notebook. आपके स्कूल लेवल में, कॉलेज लेवल में ऐसा होता था कि जो टीचर्स हैं वो आपको बचपन से ही, from your LKG, UKG, nursery onwards, and everyone is teaching you on a blackboard or a whiteboard till in your BTech and MTech. But using the presentations is not very convenient for us, because we are not really designed to, we are not having any kind of practice to study using presentations. That is why even if I show a few things using the presentations, just follow through the lectures, because I'm also going to cover some few examples based on those. And once you complete this entire chapter, जब तक आप पूरा chapter को complete करेंगे, you will be able to understand everything in a very crystal clear manner. Okay, just follow through the lectures, you will understand everything. So the first one will be introduction to the K-maps. How can you make the K-maps? Second is, we are going to take some examples using representing the functions using K-maps. Representing the functions using K-map, or you can say representing Boolean expressions. Boolean expressions using K-map. And third, we are going to look at what are the prime implicants, what are essential prime implicants, right? And what are just implicants. Because if we know what are implicants, what are prime implicants, what are essential prime implicants, it will become very easy for us to minimize any Boolean expression. And then again, we will take a lot of examples. I will take a lot of examples so that every topic, everything should be crystal clear with you guys. आप सभी के साथ सभी चीज़ें बिल्कुल अच्छे से crystal clear होनी चाहिए. Okay, let us do an introduction. How can you make K-maps? Okay, so basically K-map is dependent on a very simple expression जो आपकी Boolean expression होती है. So there are some identities of Boolean expression. So you have an identity that if you do a plus a complementation, then it is equal to 1. Based on this principle, the entire K-map is designed. तो ये जो प्रिंसिपल है आपको, you already know this principle. We have already taken a lot of examples based on these principles, and just based on these principles, K-maps are designed. Let us look at a few examples, then you will understand step by step what I'm trying to say. Okay. So we have to cover the following things. So this is just an example of K-map. This is how the K-map will look like. And I'm just showing you this as a picture because later on you will understand what I'm trying to represent using this. हम इसे क्या represent करने की कोशिश कर रहे हैं वो बाद में समझेंगे. We will come back to this later on. So let us leave it as it is and I'll come back to this one. Okay. And again you will understand this one also later on. ये कैसे represent किया है, क्या represent किया है. We are going to look at all of these things one by one. Okay. So let us skip these parts first of all. Okay. Fine. So let's start from here. So K-map is basically a graphical way of solving Boolean expressions. K-map से हम Boolean expressions को एक graphical way से solve करते हैं, right? जैसे if you have only one variable, you know that if you have only one variable, then with the help of this one variable, your function can take only two values. Either the value of a can be 0 or the value of a is 1. So this value of a0 is represented by a complement and this value of 1 is represented by a. Correct? Now if you have two variables, then there are total of 4 combinations. We have already seen this. So you can take a variable a, you can take a variable b, and with these two variables you have 4 combinations. You can have combinations as 0 0, 0 1, 1 0 and 1 1. So this 0 0 is representing a complement b complement. This is representing a complement b. This is representing a b complement, and when I say 1 1, this is representing a b. And with the help of 3 variables, there are 8 combinations are possible. Let us assume the 3 variables are a, b and c. So the combinations that are possible here are 0 0 0, 0 0 1, 0 1 0, 0 1 1, 1 0 0, 1 0 1, 1 1 0, 1 1 1. I hope it is visible. आप सभी के साथ visible होगा. Yes, it is visible. Okay. Now the first combination here is representing a complement, b complement, c complement. This is representing a complement, b complement, c. This is representing a complement, b, c complement. This is representing a, b, c. Okay. A complement, b, c. This is representing a, b complement, c complement. It is representing a, b complement, c. This is representing a, b, c complement, and this one is representing a, b, c. So these are all the combinations. Correct? I hope all of these combinations are visible. Yes, it is visible. Now when I take this K-map which is having only one variable, so I am representing this a complement using this cell and I am representing this a using this. ठीक है? तो हम a complement को इस cell से represent कर रहे हैं which is 0 and I am representing a with this cell. Fine. And when I have two variables, right? So these two variables can take 4 combinations, right? So 0 0, 0 1, 1 0 and 1 1. So this cell is representing 0 0, 0 and 0. This cell is representing 0 1. This cell is representing 1 0 and this cell is representing 1 1. Okay. And now here when you have 3 variables, so the combination with the 3 variables are total 8 combinations. So that means you can see there are total of 8 cells here. This first cell is representing 0 0 0, 0 0 1, 0 1 1 and 0 1 0. This is representing 1 0 0, 1 0 1, 1 1 1 and 1 1 0. ठीक है? There is something very interesting to notice here. Something very interesting, that when you create these combinations, I can also give them some decimal values. ठीक है? So I can allocate them some decimal values. So the decimal value of 0 0 0 is 0. This is 1. This is 2. This is 3. This is 4. This is 5. Then we have 6 and then we have 7. So we have all the decimal values which is 0, 1, 2, 3, 4, 5, 6, 7. But if you look at this cell, now these values are these combinations are given in a different manner. What do I mean to say by different manner? So if you just look at these combinations and you try to see what cell is representing which combination, then you can also represent it with the help of a decimal number. So this is representing a decimal number 0, this is representing a decimal number 1, this is representing 2 and this is 3. this is 4, this is 5, this is 6, and this is 7. Okay. Now why I do not have 1 2 0 1 2 3, but why I have 0 1 3 2? इस तरीके से क्यों है? And here also we have 4 5 7 6. We do not have 6 7. The reason is the K-map uses gray code. K-map uses gray code. ठीक है, gray code का मतलब क्या? What do I mean to say by gray code? Gray code means between any two combinations which are adjacent to each other, we should have only one bit as a different, right? Only but one bit should be different. जैसे कि let me show you with the help of an example. Let me try to show you. So if I say that we have the first bit is 0 0 0, then second is 0 0 1. So between these two only one bit is different. यहाँ पर सिर्फ एक ही bit का difference है, only one bit is different. Correct? If I say 0 1 0, now in this case between these two combinations there is a gap difference of 2 bits. So this bit is changing from 1 to 0 as well as this bit is changing from 0 to 1. Now in K-maps we any two adjacent cells can have a change of only one bit. They can have only one bit as a change. That is called as a gray code. Okay, that means instead of using this combination here, I can use the following combination. I can have 0 1 1, because if I use 0 1 1, then between these two bits, between these two combinations, I mean this entire combination and this entire combination, there is a change of only one bit. This is presenting a decimal value 0, this is representing a decimal value 1, this is representing a decimal value 3. There is a change of only one bit. In the same way, if I take 0 1 0, so between this one and this one there is a change of only one bit. सिर्फ एक ही bit का change है, and I can write it as 2. मैं इसको 2 लिख सकता हूँ. Okay, so in the same way this entire K-map is organized. पूरा K-map जो है वो इसी principle पे organized है. So if I just again write the decimal values, then the decimal values will be 0 0 0 0 0 1 0 1 1 1 0 1 0. This is 1 0 0 1 0 1 1 1 1 and 1 1 0. If you take any two adjacent cells, आप कोई भी randomly दो adjacent cell ले लीजिए, take any two random adjacent cell. Maybe I'm taking these two cells. If I'm taking these two cells, there is a change of only one bit. If I'm taking these two cells, there is a change of only one bit, right? So only one bit is changed. Even if I try to take these two cells, still there is a change of only one bit. यानी कि row में और column में. So whenever we have a row and whenever we have a column, any two adjacent cells are having a change of only one bit. And now here this adjacent cell is also having a change of one bit. Even these two adjacent cells are having a change of only one bit. So that is why we use gray code here to represent the K-map. Now what is the benefit of using the gray code? Gray code का जो benefit है वो क्या है? What is the benefit of using the gray code here? Let's try to understand the benefit here step by step. Okay. So let us assume we have this function. Let us start with the smaller function here. So this is a smaller function. This is a 2 variable function, and here this is a function f. Correct. Now let us assume this function f is assuming a value 1 here. It is assuming a value 1 here. It is assuming a value 0 in these two cases. दो लोकेशंस पे इसकी वैल्यू 1 है और दो लोकेशंस पर 0 है. If I trace out these values, if I try to put these values in the K-map, this is representing the combination 0 0, so this one will be here. This is representing the combination 0 1, therefore this one will be here. Correct? And all other locations we are having 0. Fine. And if you look at this combination is representing A combination, A complement, B complement. ये क्या represent कर रहा है? This is representing A complement, B complement, and this one is representing your A complement B. Fine. Now for this function, the expression is something like this: A complement B complement plus A complement B. I can take A complement as common, then I will get B complement dot B, B complement plus B, which is equal to A complement only. तो जो पूरा function है, this entire function can be represented by a single A complement. हम पूरे function को सिर्फ A complement की help से represent कर सकते हैं, right? Now coming back to this K-map, Here I can combine these two cells together. If I am combining these two cells together, all I have to say is what is the bit that is changing, because A is remaining constant, only B is changing. So the bits, the variable which is changing its value, I can eliminate that variable, and the variable which is not changing its value, I can say it is A complementation. तो हम इसको सिर्फ A complement से represent कर सकते हैं. That is why even using this I can find the same solution. Let me explain you with this one. ठीक है? Here what I can do is I can have a combination 1 here, I can have a 1 here, I can have 1 here, and I can have a 1 here. Let us assume these 4 locations we are having a 1, and these other locations we are having a 0. So let me also represent the same with the help of this function. Let me rub this one. So let me also represent with the help of the truth table. इसको truth table से भी represent करता हूँ so that it becomes easier for all of you guys. ठीक है? So in this case, this function is assuming a value 1 here. ये कौन सी location है? 0 1, right? So here also this function is having value 1, 0 1 2 3 4 5 6 7. So in the location 6 and 7 it is assuming a value 1. Otherwise in all other locations it is having a value 0. Correct? Now in this case I can combine these two cells and I can combine these two cells. Why I can combine? Because these two adjacent cells are having a change of only 1 bit, and these two adjacent cells are having a change of only 1 bit. So for this cell, which bit is changing? This C is changing. B is remaining the same as well as A is also remaining the same. B भी same है और A भी same है. A की वैल्यू क्या है आपके पास? 0, और B की वैल्यू क्या दोनों cells के लिए? 0 0. Therefore this combination is representing A complement B complement. Correct? In the same way, if you look at this combination here A is remaining the same, the value of A is only 1, and the value of B is also same, only these two values, which is C, the value of C is changing. Therefore I can write this combination as AB. मैं इस combination क्या लिख सकता हूँ यहाँ पर? AB. Therefore if I represent this with the help of an expression, this will be A complement B complement plus AB, which is representing A XNOR B. A XNOR B. The same can be calculated using this truth table. इस truth table से भी हम इसको same को calculate कर सकते हैं. How can you calculate? Just take these combinations. तो ये जो combination है क्या represent कर रहा है? This is representing A complement B complement C complement plus this combination is representing A complement B complement C plus this combination is representing A B C complement plus this combination is representing A B and C. From these two, I can take A complement B complement is common. I can take A complement B complement is common plus, and inside the bracket we are going to have C complement plus C plus, and from these two I can take AB as common. Inside we are going to get C complement plus C. Therefore this is 1, this is 1. Therefore we are going to get A complement B complement plus AB. So you can clearly see this expression as well as this expression, both are exactly the same. जो दोनों expressions हैं दोनों exactly same है. So basically if I represent a function using a K-map, so this is a graphical method, and solving the function using a graphical method makes things very clear for us as well as it makes things very easy. As I said, human recognition memory, humans can understand using images. आपको images ज़्यादा लंबे time तक याद रहती है. You can remember images for a very long time. You can remember the faces of the people. You can remember the photo. You can remember a picture. But if I ask you to remember a paragraph from a newspaper, you will not be able to do it, because human mind is only designed to recognize patterns. It is only designed to recognize pictures, right? तो हम लोग text को, values को, numbers को ज़्यादा लंबे time तक याद नहीं कर पाते हैं. Okay? Now again here in this case you can also see the K-map, and this is a 4 variable K-map. So if you take any two adjacent cell whatsoever, any two random adjacent cells, जैसे I can take these two adjacent cells, I can take these two adjacent cells. This cell is representing 1 1 0 1, so 1 1 0 1, right? And this cell is representing 1 1 and 1 1, correct? So here you can see only 1 bit is changed. यहाँ पर सिर्फ एक ही bit का change है, only 1 bit is changed. Hence why it is having only 1 bit is changed? Because we are using gray code. तो अगर आप कोई भी दो adjacent लेंगे cells in terms of row as well as in terms of column, only 1 bit will be changed. This is how we organize the K-map. Now in this K-map, if you check out their values, this is representing 0, 0, 0, 0, this is 0, 0, 0, 1, this one is representing 0, 0, 1, 1, this is 0, 0, 1, 0, ये वाला है आपके पास 0, 1, 0, 0, 0, 1, 0, 1, 0, 1, 1, 1, 0, 1, 1, 0, 1, 1, 0, 0, 1, 1, 0, 1, 1, 1, 1, 1, 1, 1, 1, 0, 1, 0, 0, 0, 1, 0, 0, 1, 1, 0, 1, 1, 1, 0, 1, 0. Okay, these are the cells. So if you remember, if you try to represent them with the decimal values, अगर आप इनके decimal values की तरह से represent करेंगे, this is representing value 0, this is 1, this is 2, this is 3, this is 4, this is 5, this is 6, 7, 8, 9, 10, 11, 12, 13, 14 and 15. So these are the decimal values. This is how I can represent a 4 variable K-map. इस तरीके से हम एक 4 variable K-map को represent कर सकते हैं. Clear? Okay, so 4 variable K-map will be having 16 cells. So here you can see what each of these cells are representing. If I have only one variable K-map, then one entry is representing A complement, the second entry is representing A. If I have 2 variable K-map, these entries are A complement, B complement, A complement B, AB complement and AB. Correct? Here also if you check between any two, any two adjacent cells, they are having a change of only 1 bit. वहाँ पर हमारे पास सिर्फ एक ही bit का change है. Even if you can see 3 variable K-map, you will be having a change of only 1 bit. Take any 2 random adjacent cells. Even if I take this cell, only 1 bit is changed. So here only B is changed, A is same as well as C is changed. C is also same. Even if you take this one, only 1 bit is changing, that is A. यहाँ पर सिर्फ A ही change कर रहा है, otherwise B and C both are same. Okay, so in this way you can represent K-maps. Okay, I hope it is clear. Clear? So we have 2 kinds of expression. As I told you, we have minterms as well as we have a maxterm. अगर हम लोग minterms की बात करेंगे, if you talk about the minterms, then we represent minterms as a sum of product. So they are representing all the product terms. If I talk about the max terms, that means they are representing product of sum. तो यहाँ पर जो है ये product of sum expressions है. We will look at this later on. इसको हम लोग बाद में देखते हैं. We'll try to understand it how ये कैसे काम करता है. We'll try to understand it later on. ठीक है? Okay, let us move step by step. I'll take everything in a step by step manner ताकि आपको कोई भी confusion ना हो. I'll try to explain you with the help of with clarity. Okay, तो हम सब चीज़ें बिल्कुल clarity से लेंगे. Now there are 2 ways. I mean here you can see this is the K-map for 3 variables. This is the K-map for 3 variables. But the way you are going to represent the variables, that will change their values. ठीक है, जैसे what I'm trying to say is, let us suppose that we have a function f of a, b, c. मेरे पास क्या फंक्शन है f of a, b, c. And here this function is represented as summation 1, 3, 6 and 7. Right? I hope that you remember this one. In the previous class we have covered what is summation. हमने अपनी previous class में summation को cover किया था. Okay? Now look at it very carefully because this is a little tricky things. Many people make mistakes here. So if I am representing A here and here BC, then it will be different. And here if I am representing C here and here AB, now these 2 K-maps are having few different values. Okay, I'll explain you. So this is A complement and this is A. This is B complement, C complement, B complement C, BC and BC complement. And this is representing C complement and C. This is A complement, B complement, A complement B, AB, and this is AB complementation. Okay, and if you remember, if you want to represent them with the help of a number, आप इसको नंबर से भी रिप्रेजेंट कर सकते हैं. दिस इज रिप्रेजेंटिंग अ नंबर 0, दिस इज रिप्रेजेंटिंग अ नंबर 1. ओके, तो ये जो है A कॉम्प्लीमेंट, ये नंबर 0 को रिप्रेजेंट कर रहा है. एंड व्हेन आई से A इज रिप्रेजेंटिंग अ नंबर 1. ओके, then if you have B complement, C complement, this is representing a number 0, 0, B complement C is representing number 0, 1, this is representing a number 1, 1 and this is representing a number 1, 0. So if you take any two adjacent cells, I mean adjacent bits, again one bit is changed, here also one bit is changed, here also one bit is changed, and even you can take this one and you can take this one. Between the last one and the first one only one bit is changed. Last में और first में सिर्फ एक ही bit का change है. In the same way here also, C complement means 0 and C means 1. This is 0 0 0 1 1 1 and 1 0. ठीक है, इतना clear है? Okay, see, we will do everything step by step. हम सब कुछ step by step करेंगे. I will not do anything that will make you get confused. तो हम लोग सब कुछ step by step cover करने वाले हैं. Okay. Now there's something very interesting happening here. If I'm looking at this cell is representing 0 0 0, and this cell is representing 1 0 0. Okay, why I'm writing 1 0 0 is because this row is A and here we have B complement, C complement. Now this cell is representing 0 0 0 and this cell is representing 0 0 1. मैंने यहाँ पर 0 0 1 क्यों लिखा? Why I have written 0 0 1? Why I have written 0 0 1? Why I have not written 1 0 0? यहाँ पर मैंने 0 0 1 क्यों लिखा? Because of this order. इनका जो order है, the order of variables mentioned in the function. Because of that order, I have to write these numbers in the same order, right? So here, this is representing A, this is representing B, this is representing C. This is representing A, this is representing B, this is representing C. Same order. जो फंक्शन में ऑर्डर फॉलो किया गया है वेरिएबल का, इन द सेम ऑर्डर यू हैव टू राइट दीज नंबर्स. ओके, सो हियर दिस इज प्रेजेंटिंग अगेन 0 1 0, करेक्ट. लेट मी यूज द सेम कलर. सो दिस इज प्रेजेंटिंग 0 1 0, दिस इज प्रेजेंटिंग 0 1 1, दिस इज प्रेजेंटिंग 0 1 1 0, दिस इज 1 1 1, दिस इज 1 0 0, दिस इज 1 0 1. Here if you look at this one, then this is 0 0 1, this is 1 0 1, this is 0 1 1, this is 1 1 1, this one is 0 1 0, this is 1 1 0. Okay, now because I have changed the variable that I have written here, यहाँ पर जो मैंने रो के अंदर जो वेरिएबल लिखा है, the variable I have written in the row and the variable I have written in the column, these are two different variables. So because I am using two different variables, that is why what these cells are representing, that will also change. ये जो cells जो represent कर रही है, ये भी आपके पास change हो जाएगा. Clear? Clear? Now in this case, if you write the equivalent decimal value, this is representing a decimal value 1 0, this is representing a decimal value 1, this is representing a decimal value 2, this is representing a decimal value 3, decimal value 4, decimal value 5, decimal value 6, decimal value 7. In the same way, in this case, this is representing a decimal value 1 0, this is representing a decimal value 1, this is 2, this is 3, this is 4, this is 5, this is 6 and this is 7. Again I am saying, the way you are going to represent these cells, these numberings can change. आप यहाँ पर रो के अंदर क्या वैल्यू को रिप्रेजेंट कर रहे हैं, किस वेरिएबल को रिप्रेजेंट कर रहे हैं, और कॉलम के अंदर किस वेरिएबल को रिप्रेजेंट कर रहे हैं, बिकॉज ऑफ दैट दीज नंबरिंग्स विल चेंज. ओके, आई होप इट इज क्लियर. इतना आप सभी के साथ क्लियर होगा. ओके, आई होप दिस मच इज क्लियर. ओके, फाइन. Now same thing can be observed with a 4 variable K map. Same चीजें हम 4 variable K map के साथ भी represent कर सकते हैं. Let us assume that we have the following function f of a, b, c, d, and this function is having the values summation 0, 1, 3, 7, 9, 11. 0, 1, 3, 7, 9, 11. Okay, we will see how we can represent these values. हम सभी चीजों को step by step cover करेंगे. Now what I'm doing here is I'm doing something special. I'm representing AB here and I'm representing CD here. Okay, and just for a purpose, because I want to answer something better, then I'm going to represent AC here and I'm going to represent BD here. तो यहाँ पर जो values हैं, so I've changed these values. I'm representing AC, I'm not representing BD. Right? I could have done something like this. I could have represented CD here and AB here. मैं वो भी कर सकता था, but just for fun, just to make you understand, I'm representing AC and BD. Okay. So that means ये जो cell है, the way numbering in these two cells will go, that will change. ठीक है, this is representing again 0 0 0 1 1 1 1 0 0 0 0 1 1 1 1 0 0 0 0 1 1 1 1 0 0 0 0 1 1 1 and 1 0. ठीक है, clear? Now let us write their equivalent values. So this is representing all zeros. This is 0 0 0 1. This is 0 0 1 1 0 0 1 0. This one is 0 1 0 0 0 1 0 1 0 1 1 1 0 1 1 0 1 1 0 0 1 1 0 1 1 1 1 1 1 1 1 0. This is 1 0 0 0 1 0 0 1 1 0 1 1 1 0 1 0. Okay, and in the second cell, now here it will be little tricky. Writing here will be a little tricky. यहाँ पर लिखना थोड़ा सा tricky होगा, because I have to write in this manner. I have to write first A, then I have to write B, then I have to write C, and then I have to write D. So here this value will be 0 0 0 0. Okay, so 0 0 0 1. Okay, 0 0 1 1. 0 0 1 0, again 0 1 0 0. Okay, so that means I've taken these values 0 1 here, I've written 0 0 over there. Okay, so again here 1 1, here we have 1 0, and in between we have 0 0 0 0, right? And here we have 0 1 0 1 0 1, and in between we have 0 1 here, 0 1 here, and 0 1 here. Okay, I'm so sorry, I think I've made a mistake. I've made a mistake here. I'm so sorry. I'm such a duffer sometimes. So this is representing 0 1 0 0 0 1 0 1 0 1 1 1 0 1 1 0. This is 1 1 0 0 1 1 0 1 1 1 1 1 1 1 1 0. This is 1 0 0 0 1 0 0 1 1 0 1 1 1 0 1 0. These are the values that each of these cells is representing. ठीक है, clear? Now let us write the numbers. इन सब की जो numbers हैं, let us try to understand and write the numbers for each of these cells. So this is representing a decimal value 0 1 2 3 4 5 6 7 8 9 10 11. I'm so sorry. So again, this is a mistake. This is 8 9 10 11 12 13 14 and 15. ठीक है, these will be the numbers here. Now in this second one, this is representing 0 2, correct? ये क्या वैल्यू होगी आपके पास? 2 होगी, right? And this value will be your 10. This value will be 8. This value will be 1. This is 3. This one is value which is 11, right? So we have 0 2 4 8. 8 plus 3 is 11. This one will be value 9. This is representing the value 13. This is representing the value 12. This is representing the value which is 14. This is representing 15. This one is representing value 7. This is representing a value 6. This is representing a value 4. This is representing a value 5. In this manner, they are representing some decimal numbers. ठीक है, clear है? I hope it is clear how I am going to write this. किस तरह से लिखना है वो सभी आपके साथ clear होना चाहिए. Now after this, I have written that ABCD is equal to summation 0 1 3 7 9 11. तो ये जो summation है, summation is representing the minterms, right? Minterms, or you can say the product term. So the first product term is having a value at 0. So that means here I have a value 1, and here also I have a value 1. The next we have for 1, so here I have a value 1, as well as here also I have a value 1. Okay. Next is 3. So 3 is represented here. So यहाँ पर आपके पास value 1 है, and here 3 is represented here. So here also I have a value 1. Next one is 7. So here I have a value 1, and here you can see I have a value 1. Then we have 9. So 9 का मतलब है here I have 1 and here also I have 1. Then we have 11. So 11 means here I have a value 1 and in this case also you can check here I have a value 1. तो इस तरीके से आप बता सकते हो what are the locations in the K map they are assuming a value 1. तो कहाँ का पर value 1 है यहाँ पर? We have value 1 here. We have a value 1 in these two locations. We have a value 1 in these two locations. We have a value 1 in these two locations. 1 here and 1 here. ठीक है? Clear है? Okay. So first of all, let us just understand how can you fill these values? How can you represent the functions in the K map? बस अभी आपको इतना समझना है. You only have to understand how can you represent a function using K map. Okay. Okay. So जैसे if you have a function with two variables which is AB, so I can make a K map for this AB. I'm taking a variable A here, I'm taking a variable B here, and in this function it is having 1 in 2 locations. I'm just going to represent both of these two locations using the K map. So this is representing 0 1 and this is representing 1 0. So in location 0 1 we are having a 1, in location 1 0 we are having a 1. The same thing can be done here. आप यहाँ पर भी देख सकते हैं. Actually this is only difference here is instead of writing 0 1 I have written B complement and B. Instead of writing 0 1 I have written A complement and A. So both of these two K maps are representing the same thing. दोनों जो K map है वो एक ही चीज को represent कर रहे हैं. Okay. In the same way, this is a 3 variable K map. 3 variable K map. Here we are having 3 variables. We have the variable ABC. These are representing their decimal values. जो भी combinations है, whatever combinations you have, it is representing the decimal values of those combinations. And this is representing the value of the function. तो ये क्या कर रहा है? अपनी function की value को represent कर रहा है. So this function is assuming a value 1 here, which is at the location 2. It is assuming a value 1 here, which is at the location 4. It is having a value 1 at the location 5. It is having a value 1 at the location 7. तो इन सभी location पर ये value 1 ले रहा है. So if I represent the same with the help of minterm, then I can say this is a function for the variable ABC, and this variable, this function is assuming a value 1 at the location 2. It is having a value 1 for 4. It is having a value 1 for 5. It is having a value 1 for 7. तो इस तरीके से I can also represent the same thing with the help of the function representation. Okay, and I can put all of these values in the K map. If you are putting all of these values now in the K map, these locations will be having value 1. So I think you can analyze it. आप इसको समझ सकते हैं. You can try and analyze this function. Okay. Now this is representing a 4 variable K map. So in this 4 variable K map, these are the functions which is A, B, C, D. So we have 4 variables. We have a variable A, we have a variable B, we have a variable C, and we have a variable D. Now this 4 variable K map is assuming a value 1 at the location 3, 4, 5, at the location 7, at the location 10, at the location 12, at the location 14 and 15. So I can also represent the same with the help of this. I can say the function is A, B, C, D, and this function is assuming a value 1 at the location 3, at the location 4, at the location 5, at the location 7, then at the location 10, then 12, then 14, and then 15. So these are the locations where this is having a value 1. And I can also fill all of these values in these K map. तो K map में जहाँ पर ये locations हैं, for example here I'm representing in every row I'm representing the variable AB, in every column I'm representing a value CD. Okay, and now basically it's very easy to remember these values, right? Every time you do not have to calculate that this is representing what location. You can just say it is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So just have to remember these values. ये जो numbering की values हैं, if you remember these numbering values, now filling out this K map will become very easy. इस K map को fill करना आपके लिए बहुत ज़्यादा easy या फिर बहुत ज़्यादा आसान हो जाएगा. Okay, I'll take more examples, then you will understand how easy it is to make the K maps. K maps को बनाना कितना आसान है. I'll take a few examples. So again, this is, you can see one more example. So this is a function with the help of 3 variables, and these variables are having a value 1 at A, B, C complement, A, B, C, and A complement, B complement, C. So I can make this K map. So here for rows I'm taking the variable A, and for columns I'm taking a variable BC. So the first location is A, B, C complement. So I can take A, B, this is variable A, I can take B, C complement. So this is the location which is representing A, B, C complement. Then we have A, B, C. So this is the location which is representing A, B and C. And then we have A complement, B complement, C. So this location is representing A complement, B complement and C. Okay, so this is how you can represent the same function using the K-map. Now again this is a 4 variable K-map. तो यहाँ पर आपके पास 4 variable K-map है. Now this again something easy, मतलब you can understand more easily. How you can fill this table more easily. कैसे fill कर सकते हैं? So this one is representing 0, 1, 0, 0, that is having a value 4. This is representing 0, this is 1, 0, 1, 0, that is 10. This is 0, 1, 1, 0, that is 6. This is 1, 0, 1, 1, which is the value that is 11, right? 8 plus 3 is 11. And this is 1, 1, 0, 1, which is representing a value total 13, right? So 8 plus 4 plus 1 is 13. Okay, now I can directly make a K-map, and in this K-map I can directly go to the location 4. So 0, 1, 2, 3, 4. So here we have 1, and then I can go to the location 10, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So this is location 10. So in the location 10 it is representing a value for this variable. This is representing a value of 6, 0, 1, 2, 3, 4, 5, 6. So in this location 6 I can represent this minterm. Then we have this is representing 11. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 and 11. So in the location 11 we are having a value 1. And here we have 13. So again 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 and 15. So this is representing 13. At the location 13 we are having a 1. So in this way it is very easy to fill the K-map. Making the K-map, filling the K-map is very easy. If you have 4 variable functions, K-maps are particularly used till 4 variables. अगर आपके पास कुछ functions हैं जो 4 variables के function हैं, तो हम maximum we use K-map for 2 variable function, we use K-map for 3 variable function, we use K-map for 4 variable functions. But we can also create K-map for 5 variable, but making a K-map for 5 variable is going to be very time consuming as well as it will be tricky, right? In your examination, maximum you will get up to 4 variables. आपके एग्जाम में आपको मैक्सिमम 4 वेरिएबल्स के तक ही K-map आएगा. You will not get a K-map for 5 variables. आपको 5 वेरिएबल का K-map नहीं आएगा. You will only get K-map for 3 variables as well as 4 variables. Okay. So I hope that you understood how to fill a K-map. आपको समझ में आया होगा कि K-map को कैसे fill कर सकते हैं. Okay. Now let us look at how can you make pairs in the K-map. K-map में किस pairs को बनाया जा सकता है. Let us look at in the next video. Hello everyone. In this video, let us try to understand how can you combine cells so that you can minimize a Boolean expression using K-maps. So as I told you, in the K-maps we use the gray code, and with the help of these gray codes you can combine 2 adjacent cells so that one of the variables can be minimized. Okay, so let me first show you with the help of example, then you will be able to understand. So here you can see this is representing a 4 variable K-map. So in a 4 variable K-map, any 2 adjacent cells, even if you take row wise or even if you take column wise, any 2 adjacent cells, they are having a change of only 1 bit, correct? So if they are having a change of only 1 bit, that means you can combine these cells so that you can minimize one variable. Okay, so you can make cells of size 2, you can make cells of size 4, you can make cells of size 8 and so on. I mean, the cells you are going to make will be in the powers of 2. Okay, let me explain with the help of examples, then you will understand. I'll come back to this diagram later on, and then again I'll tell you कि इसको हम कैसे कर सकते हैं, how can we do it. So look at this example here. Look at this example. We have the following expression. This is representing a Boolean expression, and this expression is representing A complement B complement C plus A complement BC. ठीक है, क्या represent कर रहा है? A complement B complement C plus A complement BC. Now in this expression, if you follow the rules of Boolean algebra, then you can take A complement and C as common, and then inside we are going to have B complement plus B. That means only one variable is changed. This is the combination. and the result will be A complement C. And the same one here can also be represented by this K map. So this K map, this location is representing your A complement, B complement C, and this location is representing A complement B C. And these are two adjacent cells, they are having only one bit of change, therefore I can combine them and I can remove the variable which is changing. So here you can see this 0 is changing to 1. So because 0 is changing to 1, so I can remove this variable here and I can write this 0 and this 1. This 0 is representing A complement and this 1 is representing C. Therefore the solution is A complement C. Now in the second case, we have the following expression. This is your Boolean expression. So in this Boolean expression, the variable A is changing. So I can represent this by this cell. So ये जो cell है, this cell is representing your A complement BC, and this cell here, it is representing your ABC. So from the rules of Boolean algebra, you can take A complement as you can take BC as common. If you take BC as common, then inside you will get A complement plus A. So because you will get A complement plus A, that is why I can remove the variable A complement plus A. You can clearly see here A is changing its value. The value of A is changing from 0 to 1, so I can remove this variable. Here you can see, here we have BC and BC are having the same values. उनकी value जो है वो constant है, वो same है. Even if we have these two cells which are on two different ends, अगर इन सभी cells के बीच में you have change of only one variable. If you have change of only one variable, then you can combine these cells. जैसे ये जो सेल है, this cell is representing the value A, B complement, C complement, and this cell is representing the value A, B, C complementation. So mathematically, I can take A, C complement as common. So here you can clearly see A is not changing its value. The value of A is same in both the cells, as well as the value of C is also same. C is having 0, C is having 0. Only B is changing its value. So because B is changing its value, so I can remove the variable B and I can get A C complement. So यहाँ से you can get A and you can get C complement. The solution will be AC complement. Okay, I'll take a lot of examples. Initially I have to explain you how to do it, but when you will do it in the practice, it will hardly take you 5 seconds to solve the problem. तो बहुत easily आप solve कर पाएंगे. First I'm trying to explain what the concept is. What is the reason behind we are going to combine the cells, and then when we will solve the problem, you will see how easy it is to solve the problems using the help of K-map. Now here, this is a 4 variable K-map, and the expression that we have is A complement B complement C complement D, and this is A B complement C complement D. So this is representing A complement B complement C complement D. This is representing A B complement C complement D. So that means in these two cells, only one variable is changing. Which variable is changing? Only this variable A is changing its value. The variable A is changing the value from 0 to 1. And all the other variables are having exactly the same value. So I can just write all the other variables here. So after writing all the other variables here, removing A, I will get B complement C complement D. So this is a solution here. तो ये आपका solution होगा. Okay. Now look at this one. Now this K map is representing 3 minterms. यहाँ पर 3 minterms है आपके पास. The first minterm is A complement B complement C. The second minterm is A complement B C complement, and the third minterm is A B C. Represent them with the help of a K map. So in this K map, we are having a 3 variable K map. So in the 3 variable K map, you are going to have total of 8 cells. Out of these 8 cells, 3 cells are having a value 1. Other cells are having a value 0. So these 3 cells which are representing a value 1, they are representing minterms. ये minterms को represent कर रहे हैं. And these cells which are having a value 0, they are representing the maxterms. वो maxterm को represent कर रहे हैं. So what I can simply do is, I can take a combination here, which is BC. I can take a combination here, which is, so in this combination, BC is same, only A is changing the value. And in this combination, A complement is same, only B is changing its value. So simply I can do, from this combination I can say it is A complement is same, as well as C is same, and from this combination I can say it is BC is same, therefore the solution will be A complement C plus BC. तो जो solution होगा वो आपका A complement C plus BC होगा. You can also do the same with the help of Boolean expression. आप इसको Boolean expression से भी कर सकते हैं. Okay, so I think here you can see we have 4 variables. आपके पास 4 variables है यहाँ पर. We have the variables which is A complement B complement C, we have A complement BC, we have ABC, and we have ABC complement. So I'm representing all of these variables here. Now there's something very interesting. Okay, so here this subset is possible. You can say this subcube is possible. We will not call it as a rectangle, we will call it as a subcube. Right? Why I'm calling it as a subcube? Because these are coming in the powers of 2. For example, 2 raised to power 0. So cell can be of having only one. मतलब जो आपका subcube है, that can be of having only one element, right? So here you can see each of these cell is representing a subcube. So that is 2 raised to power 0, a subcube of size 1. We can have subcube of size 2 raised to power 1. So here you can see this is representing a subcube of size 2. This is representing a subcube of size 2. This is representing a subcube of size 2. We can also have subcube of size 2 raised to power 2. That means 4 cells. We cannot combine 3 cells in a K-map. We can combine 4 cells. We can have a subcube of size 2 raised to power 3. That is 8 cells. We can have a subcube of size 2 raised to power 4. That is 16 cells. So basically, whenever you are going to combine these variables, these subcubes are having a size which is in the powers of 2. The size of each of these subcube will be in the power of 2. Okay? Now in this case, if you look at it very clearly, यहाँ पर क्या हो रहा है? So both of these ones are included in this subcube, as well as both of these ones are included in this subcube, but these two ones are included in two different subcubes. ये जो दो ones हैं, I mean this one and this one, they are included in two different subcubes. ये दो अलग-अलग subcubes में included है. So we do not have to take it. हमें को नहीं लेना है. Why we do not have to take it? Because this is not an essential prime implicant. ये एक essential prime implicant नहीं है. Okay, so we will discuss about it. हम लोग इसके बारे में discuss करेंगे. Step by step we are going to discuss about it. Just now, just know that we have three terminologies. One is we have implicant. One is we have implicant. Second is your prime implicant. Prime implicant. Correct? And the third one is your essential prime implicant. Third is essential prime implicant. तो हमारे पास तीन टर्मिनोलॉजीज हैं यहाँ पर. एक है implicant, दूसरा है prime implicant और तीसरा है essential prime implicant. Let me give you a brief idea. अभी मैं I'm not discussing in depth regarding implicant, prime implicant or essential prime implicant. We will discuss about these three terminologies in the next video. Right now, let me just give you a brief idea. So every subcube is an implicant. Even if we have a subcube of size 2 raised to power 0. जैसे if I just talk about this single one, this is an implicant. This single one is an implicant. This single one is an implicant. This single one is an implicant. So every subcube, right, is an implicant. Even you can see this is a subcube of size 2. It is also representing an implicant. It is a subcube of size 2. It is also representing an implicant. It is a subcube of size 2. It is also representing an implicant. Implicant means every subcube is an implicant. And the size of subcube will be 2 raised to power 0, 2 raised to power 1, 2 raised to power 2, 2 raised to power 3, 2 raised to power 4. Any of these subcubes will be representing an implicant. Clear? Then we have prime implicant. Prime implicant means any implicant which is not completely a part of another subcube, which is not completely a part of another implicant. जैसे let me explain with the help of example. देखो, this one is representing an implicant. This one is representing an implicant. But the problem here is both of these ones are also a part of third implicant. ये जो दोनों वन है वो एक तीसरे implicant के अंदर भी आता है. Both of them are coming within this third implicant. So basically this third implicant which is not inside another implicant, then that is called as prime implicant. This is called as prime implicant. जैसे let me show you here. So this one and this one simple, these both are implicant, but this bigger subcube is a prime implicant. Now this one is an implicant, this one is an implicant, correct? But this bigger one is a prime implicant. Then you can say, sir, ये जो bigger subcube है, for this bigger subcube, some part of this subcube is coming in this implicant, and some part of this bigger subcube is coming in this subcube, right? तो इसका कुछ part है जो इस वाले subcube के अंदर आता है, कुछ part है इस वाले subcube के अंदर आता है. So that means see this subcube is not entirely a part of another one. मतलब entirely का मतलब क्या है? You have a box and you are putting something inside the box, right? This something is completely inside the box. अगर ये completely इस box के अंदर है, इसका मतलब है this box is a prime implicant and this inside one is a only implicant, correct? But if some part of this box is coming in this box, some part of this box is coming in this box, right? Then we will not call this one as a implicant. This will become a prime implicant, correct? So basically every prime implicant is also an implicant. हर एक prime implicant जो है वो एक implicant को represent करता है, okay? Then third one is essential prime implicant. तो essential prime implicant का मतलब क्या है? Is there any prime implicant which is covering a one which is not covered by anyone else? जैसे if you look at this implicant, ये जो implicant है, this implicant is a prime implicant, right? But at the same time this implicant is also essential prime. ये जो implicant है यहाँ पर, ये एक essential prime implicant भी है. Why? Because it is covering this one and this one is not covered by any other subcube. इस one को किसी भी subcube ने cover नहीं किया. And here in this subcube is also essential prime implicant because it is covering one term. ये एक ऐसी term को cover कर रहा है that is not covered by any other prime implicant. But if you look at this subcube here, this subcube, so this subcube is just an implicant, but it is not essential prime. This subcube is just a prime implicant, but it is not essential prime. ये सिर्फ एक prime implicant है, ये essential prime implicant नहीं है. It is not representing an essential prime implicant. Why it is not representing an essential prime implicant? Because it is not covering anyone that is covered by others. मतलब ये कुछ ऐसी term को cover नहीं कर रहा जिसको कोई और cover ना कर रहा हो. ये दो terms को cover कर रहा है and both of these two terms are covered by other essential prime implicants. ठीक है? So in any of your solutions, we should have all the essential prime implicants. जैसे this is representing an essential prime implicant. This is also representing an essential prime implicant. So in any of your solution, all of your essential prime implicants should come, right? But for prime implicants, we have to choose whether this prime implicant should come or should not come. So if I am giving a solution for this equation, now this one should be present in the solution. ये जो है ये किसको present कर रहा है? A complement C. And this one is also essential prime implicant. ये किसको represent कर रहा है? AB. So in any of your solution, all the essential prime implicants should be there. But for some prime implicants, we have to choose whether it should be there in the solution or it should not be there in the solution. Okay? We will discuss about it. हम इसके बारे में ज़्यादा डिटेल में discuss करेंगे. We are going to have a complete discussion about it. Even if you could not understand anything, even if you just know कि हमारे पास ये तीन terminologies है, as of now that is fine. You should only know that there exists a terminology which is implicant, there exists a terminology which is prime implicant, and there exists a terminology essential prime. अभी आपको सिर्फ ये तीन terminologies को करना है because we are going to have a complete video, we are going to have a complete discussion on this topic. Okay, right now just understand. For this K-map, we can get multiple solutions, but here if I say I want to have a unique or I want to have a minimized Boolean expression, so in that minimized Boolean expression, all the essential prime implicants should be there, and for prime implicants, we have to make a choice. Okay? If you solve the same expression using Boolean rules, how can you do it? From these two, I can take A complement C as common. From these two, I can take AB as common, and then B plus B complement is 1, C plus C complement is 1. Therefore, the solution is A complement C plus AB. Okay? Okay, let me take another example here. So, in this example, we are creating a subcube of size 4. यहाँ पर जो subcube है, उसका size 4 है. And all of these 4 cells should be adjacent. ठीक है? जैसे in this case is representing an expression. ये किस expression को represent कर रहा है? This is representing a function f of ABC, and in this ABC we are having summation 4, 5, 6 and 7. It is having summation 4, 5, 6, 7, 7. That means it is having 4 minterms. Now when you are putting all these 4 minterms here, now in this case there are a lot of implicants are possible. There are a lot of essential prime. Okay, let me show you implicant क्या है यहाँ पर, essential prime implicant क्या है. How many implicants are there and how many essential prime implicants are there? First of all, let us just look at what are the number of implicants. यहाँ पर कितने implicants हैं? What are the number of implicants? So this single one is an implicant, second implicant, third implicant, fourth implicant. Then we have 5 implicant, 6 implicant and 7 implicant. And then this bigger one is your 8 implicants. So in this one we have a total of 8 implicants. आपके पास यहाँ पर 8 implicants है. We have a total of 8 implicants. Clear? Then how many implicants are there which are prime implicants? यहाँ पर अगर आपके पास 8 implicants हैं तो इन 8 में से कितने prime implicants हैं? How many of them are prime implicant? Okay. So this bigger subcube here, this bigger subcube is only one prime implicant. यहाँ पर prime implicant सिर्फ एक ही है. It is only having only one prime implicant. We do not have more than one prime implicant, because even if you take this subcube, so this subcube is a part of this bigger subcube, correct? So this cannot be a prime implicant. Even if you take this subcube is also a part of this bigger subcube. So the biggest subcube that you can have, the biggest subcube that you can make, that biggest subcube is going to represent a prime implicant. Okay? And how can you make subcube? आप subcube कैसे बना सकते हैं? You can only combine those cells where there is a change of only one bit, right? So here between these two cells, only one bit is changed. Between these two cells, only one bit is changed. Between these two cells, only one bit is changed. That is why I can combine this subcube of size 4. And when you look at this subcube, then what are the variables that are changing? So C is changing as well as B is also changing. So B and C both are changing. Only variable that is remaining the same is A. Therefore, because only A is remaining, so I can say that this entire K map is representing only the variable A. In the same way, if you look at this K map, now in this K map, we have all of these locations are representing a 1. ठीक है? तो अगर आप इसको थोड़ा ध्यान से देखेंगे, if you look at it very clearly, then you will find that this is representing a function f of a, b, c, d, which is equal to summation 3, 7, 15, right, and 11. ठीक है? So it is representing summation 3, 7, 15, and 11. Okay. Now again here you can combine subcubes. So this is the biggest subcube you can have, and this biggest subcube is representing a prime implicant as well as it is also representing essential prime implicant. Now in this biggest subcube, only CD is not changing. CD is remaining the same. A and B both are changing their values. Therefore, if you look at the solution is CD, right? Solution जो है वो यहाँ पर होगा CD. Okay. Now look at this one here. So here 3 examples are there. How are the other subcubes you can make? Now in this example, you can combine these 4 cells. Why I can combine these 4 cells, sir? Why? Because here, first of all, it is having a size of 4. And if you look at these 2 cells, only one bit is changed. If you look at these 2 cells, only one bit is changed. If you look at these 2 cells, only one bit is changed. But if you look at these 2 cells, only one bit is changed. So basically, we can have a subcube of size in the powers of 2. So this is 2 raised to power 2. So the subcube of size 4. Okay. Here again, if you look at this cell and this cell, only one bit is changed. Why? Look at this cell. This cell is representing A, B, C complement, D complement, and this cell is representing A, B, C, D complement. So here you can see only C is changing, and A, B, D complement is same. So that is why I can combine this subcube and this subcube. In the same way, I can combine this subcube and this subcube. In the same way, I can combine these 2 subcubes and these 2 subcubes. So I can take a subcube of size 4. तो यहाँ पर मैं subcube जो है उसका size 4 ले सकता हूँ. I can take a subcube of size 4. Now in this subcube of size 4, what variable is not changing? You will see A is not changing. As well as you can see that D is not changing. C is changing as well as B is changing. Therefore, in your solution, you will get A, D complement. The solution of this K map is AD complement. Okay? So you can clearly see it is AD complement. And if you look at this K map, again you will find that this subcube and this subcube, only one bit is changing. This subcube and this subcube, only one bit is changing. This subcube and this subcube, only one bit is changing. This subcube and this subcube, only one bit is changing. So I can combine all of these 4 corner subcubes. जितने भी आपके corner के subcube है, आप सभी को combine कर सकते हैं. And if you combine all of these 4 subcubes, then you will see that D is not changing here, as well as B is not changing here, that means the solution will be D complement and B complement. So we have BD complement. Okay, so this is basically B complement dot D complement. ये B complement dot D complement है, so there is some printing mistake. You can rectify the mistake. Here also it is A D complement. Here is B complement dot D complement. Okay. Now again here, but you can see we have one in this location. We have one in this location, one in this location, one in this location, one in this, one in this, and one in this. Now in this case we cannot have a subcube of size 7. हमारे पास size 7 का subcube नहीं हो सकता. The subcubes can be of size 2, the subcubes can be of size 4, the subcube can be of size 8. We cannot have a subcube of size 7. So now what I can do here is I can make this subcube, it is of size 4. I can make this subcube, it is of size 4. I can make this subcube, it is of size 4. So basically in every question, in every K-map, we always have to try and make the biggest subcube which is possible. हमें सबसे बड़ा subcube बनाना है. We try to make one of the biggest subcube, correct? तो यहाँ पर what you can even do is, you can do it something like this. You can only combine these two ones, but that will not create a biggest subcube. When you create a biggest subcube, in that case, the number of variables that it can represent can also be, you know, जो number of variables ये represent कर सकता है, उसको हम minimize कर सकते हैं, or you can say minimize the number of literals. Now, if you look at this entire subcube here, इस पूरे subcube में AB is remaining and everything else is changing. So AB will be in the solution. In this subcube, only AC is not changing, others are changing. In this subcube, only AD is not changing, others are changing. Okay, ठीक है, clear है? Now there is something very interesting property. यहाँ पर एक बहुत ही interesting property है. There is something very interesting. देखो, this is representing the number of variables in a function. Number of variables in a function. Okay, fine. And this is representing the size of subcube. This is representing the size of subcube. इसको थोड़ा सा ध्यान से समझिएगा. Please focus on it clearly. So this K-map is representing a total size of, this K-map is having a total 4 variables. How many variables are there? We are having 4 variables, which is A, B, C and D. We are having 4 variables. Total 4 variables are there. ठीक है? Now what is the size of this subcube? इस subcube का size कितना है? So this subcube is having a size of 4. So if this subcube is having a size 4, now this 4 can be represented by 2 raised to power 2. 2 raised to power 2. Now this 2 is important. ये जो power वाला 2 है, this 2 which is coming in the power, this 2 is important. Why this 2 is important? Because in this subcube which is of size 4, the number of variables will be 4 minus 2. ये 4 कौन सा है? The number of variables. ये 2 कौन सा है? This 2. Okay? Clear? Okay, let me explain you. Let me explain you one more time. देखो, if I make a smaller subcubes, अगर मैं if I try to make only this subcube, अगर मैं आपको सिर्फ ये वाला subcube बनाने की कोशिश करता हूँ, थोड़ा फोकस कीजिएगा, please focus here. If I try to make only this subcube, right? So this subcube is of size 2. That means 2 raised to power 1. 2 raised to power 1. Now the minterm that this subcube will be representing, ये subcube जिस minterm को represent करेगा, that minterm will be having 4 minus 1 variables. इसकी जो भी minterm बनेगी उसके अंदर 4 minus 1 variables होंगे. 4 कहाँ से आया? Total number of variables are 4. ये 1 कहाँ से आया? That is 2 raised to power 1. So जितना भी subcube का size है, जो उसकी power है, उसको अगर आप 4 से subtract करेंगे, then you will find out that how many variables can be minimized. अगर आप इस subcube को check करेंगे, then you will find out that A is not changing, B is changing, as well as C complement and D is remaining the same. तो C complement और D है, वो यहाँ पर same है. So this subcube will be of size, क्या size होगा इसका? This subcube is of size 2, therefore 3 variables will be there. यहाँ पर 3 variables होंगे. Okay, let me take more examples, then you will understand. Okay, so we have this expression. Let us try to first minimize this expression, then maybe you can understand from this. Okay, So here this is a function of 3 variables. Function कितने variables का है आपके पास? 3 variables का है. So I'm going to make a K-map with 3 variables. Okay, so a 3 variable K-map will be having total of 4 cells. So I'm taking a variable A here, I'm taking a variable B and C here. ठीक है, step by step I'm doing everything ताकि आप सभी को समझ में आए. If you, I think you should be able to follow me. आप सभी मेरे को follow कर पाएंगे इसके बाद. I want all of you कि आप मुझे इसके बाद follow कर पाए. Okay, now this is representing a 3 variable K-map. So this location is representing 0, this is representing 1, this is 0 0 0 1 1 1 1 0. ठीक है? Okay. Now the first value here is A B complement C. That means 1 0 1. 1 0 1 मतलब 5. ठीक है? So I can also give them a number. मतलब basically क्या होता है कि if you give them number, it becomes very fast to solve these equations. तो I do not really need to write this. मुझे ये लिखने की जरूरत नहीं है. I do not have to write it. Why I do not have to write it? I can just directly give it number. I can say it is cell number 0, cell number 1, cell number 2, cell number 3, 4, 5, 6 and 7. Now this is representing value 5. This is 0 0 1 which is 1. This is 0 1 1 which is 3. This is 1 0 0 which is 4. This is 0 0 0 which is 0. अब आप clearly कह सकते हैं ना, you can clearly say that at location 0 we are having a 1. At location 4 we are having a 1. At location 3 we are having a 1. At location 1 we are having a 1. At location 5 we are having a 1. So these are the locations जहां पर आपके पास 1 है. Clear है सबके साथ? Is it clear? अब थोड़ा सा ध्यान दीजिएगा because this part is little tricky. अब थोड़ा सा tricky part आएगा, so I want all of you to focus here. So I want to make the biggest subcube that is possible. जो सबसे बड़ा subcube possible है मैं वो बनाना चाहता हूँ. तो I can make this subcube. Correct? This is the biggest subcube. So this one will not be included in this. Why? Because the size of subcube will only be in the powers of 2. Secondly, I can make this subcube. So this subcube is also essential prime implicant, as well as this subcube is also essential prime implicant. ठीक है? अब कुछ चीजें एनालाइज करते हैं before I give you the solution. Let me analyze a few things here. So the size of this entire subcube is 4. ठीक है? क्या साइज है इसका? 4. And 4 can be written as 2 raised to power 2. ठीक है? यानी कि इस सबक्यूब से जो भी मेरे पास एक्सप्रेशन आएगी, that expression will be having 3 minus 2 is equal to 1 variables. उस एक्सप्रेशन में सिर्फ एक ही वेरिएबल होगा. What is 3? 3 is the number of variables in this expression. What is 2? 2 is the power. ठीक है? So let us look at this one. 0 1. This is 0 0 and this is 0 1. So we can clearly see A is changing as well as C is changing. The only thing that is not changing is B. So from this subcube I can find out B complement. ये जो subcube है वो सिर्फ B complement को represent कर रहा है. That means only one variable is there. Okay. Now let us look at the second one. If you look at this subcube here, the size of this subcube is 2, and 2 can be written as 2 raised to power 1. 2 क्या लिख सकते हैं हम लोग? 2 raised to power 1. So now we have 3 variables, and if I do 3 minus 1 that is equal to 2, यानी कि इस subcube से मेरे पास जो term आएगी, the expression that I will get, in that expression only 2 variables will be there. जैसे what I can do here is, if you look at it here, A is not changing, right? So it is 0 0 0 1 and 1 1. So A is not changing, only C is changing. C change कर रहा है, B is also not changing. Therefore, this one is representing A complement and B complement. ये जो subcube है, I'm so sorry, C is not changing, only B is changing. C जो है वो change नहीं कर रहा, सिर्फ B change कर रहा है. Okay, so B is changing from 0 to 1, but C is remaining the same. C जो है वो 1 है, therefore here I will get A complement C. यहाँ से मुझे क्या मिलेगा? A complement C. Therefore, what is the solution here? What is the solution equation? The solution will be B complement plus A complement C. Solution होगा आपके पास B complement plus A complement C. This is the solution equation for this given expression. ठीक है? ये इस expression के लिए solution equation होगी. Okay? I hope you understood this. आप सभी को ये solution समझ में आया होगा. Let us do one thing. In the next video, let me take few examples. Let me take few examples of some Boolean expressions, and let me try to solve those Boolean expressions. Okay, we'll meet in the next video now. Hello everyone. In this video, we are going to look at some of the examples of K-map. And remember, all the K-maps, all the expressions that I'm solving so far, all of them are sum of product expressions, or you can say SOP expression. I have not taken any product of sum expressions that I will take in the next video. So right now, we are just solving some expressions, some Boolean expressions using the K-map. And I just wanted to give a brief idea behind this. Then again, we will learn a lot more concepts, a lot of new concepts in the next video. Okay, so before moving ahead, let us look at these examples. So this example here, we are having 4 variables. The variables are A, B, C, D, and we want to minimize this expression. Kaise minimize karenge? Let us look at this one. So for 4 variables, we are going to have a K-map which is going to have 16 entries. There are 16 combinations of 4 variables. Okay. Now here, because we have the variables A, B, C, D, I'm going to take A, B here and I'm going to take C, D here. Clear? Now let us number them. This is 0, 0, 0, 1, 1, 1, 1, 0, 0, 0, 0, 1, 1, 1, 1, 0. And I can number each of these cells. I can say this is cell number 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 and 15. In this way I can number each of these cells. Now let us look at these expressions. So this is representing 0, 1, 0, 0. Yani ki this number is 4. This is representing 0, 1, 0, 1, which is 10. Sorry, this is not 10, this is 5. This is 5. This is representing 1, 1, 0, 0, which is 12. This is 1, 1, 0, 1, which is 13. And this is 1, 0, 0, 1, which is 9. 0, 0, 1, 0, and there is 2. So that means these locations are having 1. Kaun si location hai? We have 4, here we have a 1, we have 5, here we have a 1, we have 12, 1, 13, 1, 9, here we have a 1, and we have 1 at the location 2. So यहाँ पर अब आपके पास 1 है. These are the locations where we have 1. So what are the subcubes possible? यहाँ पर क्या क्या subcube possible है? I can make this subcube. So you see, I want to make a subcube which is as big as possible. I want to have big subcubes, because if I can make big subcubes, then I can minimize the number of variables. Okay. And now the second subcube that I can do here is, this is your second subcube. And now this one cannot be combined with any subcube. इसको हम किसी भी subcube के साथ combine नहीं कर सकते, because we could have combined this with the corners. I mean, this could have combined with this, or this could have combined with this, or we could have combined this one with this one or this one, right? But again, there is no other one here. So I cannot combine this one with anyone. So this is again an implicant which is also essential prime. So this one here, if I look at this subcube, in this subcube variable B is same, variable B जो है वो same है, as well as variable C is same. So this is representing B C complementation. Okay, and for this subcube the variable A is same, as well as the variable CD is same, variable B is changing. So it is A C complement D. And for this subcube we have A complement, B complement, and then we have C D complement. Therefore, if I can add all of them, then my solution equation will be BC complement plus AC complement D plus A complement B complement C D complement. So you can clearly see how easy it was to solve this expression. इस expression को solve करना कितना आसान था, right? It hardly took me 1 or 2 minutes to solve this entire expression. If I solve the same expression using the laws of Boolean algebra, then it might take me a lot of time, plus there's a chances of mistake. Here the chances of mistakes are very less. Let me take the next example here. So in this case, again this is a 4 variable function. So again I have to make a K-map with 4 variables. Okay. So you can also note down the amount of time that it will take me to solve. I'm trying to explain at the same time also trying to solve. So it will not take me hardly 1 or 2 minutes to solve this one. So I can say it is 0, 0, 0, 1, 1, 0, 1, 1, 1, 0, 0, 0, 0, 1, 1, 1, 1, 0, and the locations are 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 and 15. ठीक है. अब यहाँ पर ये जो लोकेशंस है, दिस इज रिप्रेजेंटिंग अ वैल्यू 0, 0, 1, 0 which is 2. This is 1, 1, 1, 0 which is 14. This is 1, 0, 1, 0 that is 10. This is 1, 0, 1, 1 that is 11. This is 1, 0, 0, 8. This is 1, 1, 0, 0, 12. This is 0, 0, 1, 1, 3. This is all zeros. Okay, so that means we have a value 1 at the location 2. We have a value 1 at the location 14. We have a value 1 at the location 10. We have a value 1 at the location 11. We have a value 1 at the location 8. Then we have a value 1 at the location 12. Then we have a value 1 at the location 3. And then we have a value 1 in this location, right? So these are the ones that we have. Now I want to make the subcube as big as possible. जितने बड़े subcube हम यहाँ पर बना सकते हैं, I want to make the subcubes as big as possible. Okay, let me show you क्या क्या subcube बन सकते हैं. So what I can do here is I can combine these 4 ones. मैं इन 4 ones को एक साथ combine कर सकता हूँ. So this is a subcube of size. This is a subcube of size. You know how much size it is? This is a subcube of size 4. At the same time, I can combine all the ones in the corner. So all these ones in the corner, I can again make one more subcube of size 4. तो ये मेरे पास एक और subcube बनेगा जिसका size 4 है. And at the same time, I can also make one more subcube which is of size 4. So I can combine these 2 ones with these 2 ones. So I can have, so you can clearly see here, I can make total of 3 subcubes and the size of each of these subcube is 4. हर एक subcube का size 4 है. So because size of each of these subcube is 4, so this expression can be minimized to only 6 liters. For with every minterm, I'm going to have only 2 variables. Let me write all of them one by one. ठीक है? Let me take the first green one. सबसे पहले मैं green को लेता हूँ. Let me try to explain what this green is representing. So in this green one, we have A is same as well as D is same. So this is representing A and D complementation. ये AD complement को represent कर रहा है. Okay? And let us suppose I'm taking this one. So in this one we have B complement is same. B complement आपके पास same है. At the same time D complement is same. So this is representing B complement and D complement. ये B complement और D complement को represent कर रहा है. If I take this yellow one, अगर मैं इस yellow वाले को लूँगा, so in this yellow one we have B complement here, B complement. And at the same time C is there, so it is B complement C. Therefore the solution, the equation that I can have here, the solution equation is A D complement plus B complement D complement plus D complement B complement C. This is representing B complement C. So sorry, this is B complement C. So this will be the solution equation for this given function. So you can see how easy it was to solve this question. तो इस तरह के जो questions हैं, these are such a difficult questions, they are such a big questions, and it becomes very easy to solve such questions regarding with the help of K-map. If you try to solve the same question without using the K-map, it will take a lot of time. आपका काफी time जो है इस question में waste होगा. So using the K-map, things become very easy, things become very simple. Now let us take this next example. So as you can see, this is a very big question here. So here we are having a K-map. I think I just have to skip the yes. So here we have a K-map, which is a 4 variable K-map. I think I've solved it. Let me check again. This is done, this is done, this is also done. Yeah, so here again we are having a 4 variable K-map. So in this 4 variable K-map, this is your K-map. This is representing AB. This is representing CD. Here we have 0, 0, 0, 1, 1, 1. This is basically 1, 1. This is 1, 0. Again 0, 0, 0, 1, 1, 1, 1, 0. And the values in these locations are, let me write them out. So this is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 and 15. Okay, and now let us analyze what are the locations where this function is assuming a value of 1. So this is 0 0, this is 0 0 0 1, which is equal to 1 only. This is 0 1 0 1, which is 5. This is 0 1 1 1 7. This is 6. This is 12. This is 13. This is representing 15, and this is representing 11. Okay, so 1 here we have a 1, then 5 here we have a 1, 7 here we have a 1, then we have 6 here we have a 1, at 12 we have a 1, 13 we have a 1, and 15 we have a 1. So these are the ones that we have. Okay, let us try to make the subcube. I can make this subcube. It is a very big subcube, correct? And at the same time I can also make this subcube, I can make this subcube, I can make this subcube, and here you can see we also have 11. So 11 is also there. That means I can also make this subcube. So this is the K-map, and these are the subcubes that are possible. Now in these subcubes you will identify that all of these orange subcubes, they are essential prime implicants. ये जो है ये essential prime implicant है. Here it is also representing an essential prime implicant. Here it is also representing an essential prime implicant. Here it is also representing an essential prime implicant. But this blue subcube, ये जो blue आपके पास आया है, this is just a prime implicant. It is not essential prime. So basically in our solution, every essential prime implicant should be there. But for the prime implicant, we have to make a choice whether we want to take it or not. But here you can see this prime implicant, all the terms that are present in this prime implicant, all of these terms are covered by essential prime. So basically ये जिस वन को कवर कर रहा है उसको बाकी सभी कवर कर रहा है, बाकी सभी essential prime को कवर कर रहा है. इसके अंदर कोई ऐसी एक्स्ट्रा टर्म नहीं है जो कि दूसरे essential prime कवर नहीं कर रहे, right? So that means in our solution I do not need this subcube. इसकी मुझे कोई भी जरूरत नहीं. Even though I can add it, but still further minimization is possible. I do not need this subcube. So I'll take the concept of essential prime, then you'll understand that why I do not need it. So for as of now, let us try to give a solution. Okay, so this subcube is representing A, B and C complement, and this subcube is representing C, D and A. This subcube here, this one is representing your A complement, B, and this is C, right? So here A complement, B and C, and this subcube is representing your A complement, C complement and D, right? So that means in our solution, your solution equation will be A, B, C complement plus A, C, D plus A complement, B, C plus A complement, C complement, D. So this is the solution equation. These are the minimum number of literals in this solution equation. तो इस solution equation में ये सभी minimum number of literals हैं. Okay, so I hope that you understood the solution. आप सभी को solution समझ में आया होगा. Any doubts? अगर कोई भी doubt है, please feel free to ask your doubts. Now in this case, this expression, how many number of literals are there? 1, 2, 3, 4, 5, 6, 7, 8. So there are 8 into 4, or you can say 32 literals are present in this entire expression. उस पूरी expression में 32 literals हैं, but this minimized expression is only having 12 literals. जो हमारी minimized expression है उसके अंदर सिर्फ 12 literals हैं, और इस पूरी expression में हमारे पास 32 literals थे. Okay, so you can clearly see how much we have minimized that given expression. Okay, so again here this time I'll take a function. Instead of taking an expression, I'll take a function and I'll try to represent this function using the K-map, and I'll try to minimize this function. So here this is a 3 variable function. ये आपका जो function है ये 3 variable function है. So because it is a 3 variable function, that is why I need a K-map which is having 8 cells. Okay, these are all the 8 cells. Here we have A, here we have B and C. This location is 0, this location is 1. So here 0, 0, 0, 1, 1, 1, 1, 0. These locations are 0, 1, 2, 3, 4, 5, 6 and 7. ये सभी आपके पास locations हैं. So this is the decimal number 0. This is the decimal number 3. This is the decimal number 4. This is not there, right? So it is not there, and this is the decimal number which is 7, right? So that means at the location 0, 3, 4, and 7. In these locations we are having 1s. In सभी locations पर आपके पास 1 है. Now I can make a subcube here. क्या क्या subcube बना सकते हैं? I can make this as a subcube. I can make this as a subcube. We cannot combine them. हम इनको combine नहीं कर सकते because between this and this variable, or you can say between this and this location, there is a change of 2 bits. Because there is a change of 2 bits, we cannot combine them. So I can have only two subcubes here, and both of these 2 subcubes are essential prime implicants. So this is representing B complement C complement, and this is representing BC. Therefore the solution to this given equation is B complement C complement plus BC, or you can say B x NOR C. Solution क्या होगा आपके पास? B x NOR C. So in this manner you can solve this equation. As you can see, solving it is so easy and so simple. कितना आसान है इस equation को solve करना. Okay. So now again this is the question for you. आप सभी को ये question लेना है. Please try to solve it. I've taken this question for you. आप सभी को ये question solve करना है. Okay. Now in the next video, in this next session, let us try to identify what are prime implicants, what are essential prime implicants. Okay. And let us try to solve more questions based on that. We will meet in the next video. Hello everyone. In this video, let us look at what are prime implicants, what are essential prime implicants, what are selective prime implicants, and what are redundant prime implicants. In the previous video, I've already given you a brief idea regarding all of these implicants. मैंने आपको एक brief idea दिया था. In this video, let us study about these things in more details. इन सभी चीज़ों को हम और ज़्यादा details के अंदर study करेंगे. Now in this diagram, you can see that there are 3 prime implicants. But let us first of all analyze what are the number of implicants, and out of all those implicants, what are the prime implicants. Okay, so any subcube here is a implicant. So we can have a subcube of size 1, we can have a subcube of size 2, we can have a subcube of size 4, we can have a subcube of size 8, we can have a subcube of size 16, and so on. I mean in the powers of 2. Now in this case, this is subcube of size 1. It is an implicant. This is subcube of size 1. It is an implicant. Subcube of size 1. Subcube of size 1. These all are representing implicants, and these all are your trivial implicants. ये जो implicants हैं ये हमेशा trivial होंगे. Now this is also an implicant, right? So this is the 5th one. This is also an implicant. 6th one. This is also an implicant. 7th. So you can see there are a total of 7 implicants in this example. Out of these 7 implicants, there are only 3 implicants which are called as prime implicant. इन सभी 7 में से हमारे पास 3 ऐसे implicant है जिसको हम prime implicant बोलेंगे. ठीक है? So that means so I told you what is a prime implicant. So any implicant which is not completely inside any other implicant. जैसे if I say this is one implicant and this is another implicant. So this implicant is completely inside this implicant. Therefore I can say this bigger one is your prime implicant. So if something like this happens, that this is an implicant and this is another implicant, right? So this is also a prime implicant and then this is also a prime implicant. But if I have an implicant here, it is not a prime implicant. If I have an implicant here, it is not a prime implicant. If I have implicant here, it is not a prime implicant. So I mean any subcube which is not completely a part of any other subcube. जैसे यहाँ पर ये जो बड़े वाला subcube है, it is not coming inside any other subcube, right? So it is a prime implicant. So in the same way, if you look at this example, now in this example, this is a subcube which is not completely coming inside any other subcube. So this subcube is representing your prime implicant. This subcube which is not completely a part of any other subcube, therefore it is a prime implicant. As well as this subcube is also completely not a part of any other subcube, it is a prime implicant. So now let us look at what is the essential prime. यानी कि जितने भी आपके prime implicant है, if there is any prime implicant which is at least covering one term that is not covered by others, that is called as your prime implicant, right? So here this is a prime implicant, this is a prime implicant, as well as this is also a prime implicant. But out of these 3 prime implicants, only this implicant as well as this implicant, they are called as essential prime. सिर्फ 2 ही हमारे पास ऐसे implicant है यहाँ पर जिसको हम essential prime बोलेंगे. Why are we going to call them as essential prime? Because at least they are covering one term that is not covered by others. बिकॉज ये वाला जो प्राइम इम्प्लीकेंट है ये किसी भी ऐसे टर्म को कवर नहीं कर रहा जो इसको कोई और कवर ना करो. इट इज कवरिंग टू टर्म्स बट बोथ ऑफ दीज टू टर्म्स आर कवर्ड बाय अदर्स, राइट. तो ये इसी वजह से ये जो आपका एक प्राइम इम्प्लीकेंट है इट इज नॉट अ एसेंशियल प्राइम इम्प्लीकेंट. Okay, so you can read the definition also. So these are those subgroups which cover at least one minterm that cannot be covered by any other prime implicant. Essential prime implicants are those prime implicants which always appear in the final solution. They will always be in the final solution. The minimal expression will always contain essential prime implicants. And then we have redundant prime implicants. So those essential prime implicants, those prime implicants which are not essential, they are called as redundant. For example, here in this example you can see that this is your essential prime implicant, this is also representing your essential prime implicant, but this one is not your essential one. This is redundant prime implicant. इसको हम बोलेंगे redundant. Okay. Then we have selective prime implicant. Selective prime implicants क्या? Just read the definition once. The prime implicants for which are neither essential nor redundant prime implicants are called as selective prime. These are also known as non-essential prime implicant. They may appear in some solution and may not appear in some solutions. यानी कि ऐसे prime implicants जो कि ना तो essential है और ना ही redundant है, they are neither essential nor redundant, then we call such prime implicants as selective prime implicants. I'll show you with the help of examples. I'll cover more examples here where you will learn what is a selective prime implicant. So in this example here, we have this is, okay, so let me just come back here. So here you can see this is representing an essential prime implicant because it is covering one term that is not covered by others. This is representing one term that is not covered by others. Therefore this one and this one, both of them are essential. ये वाला और ये वाला, ये दोनों essential है. लेकिन अब ये वाली टर्म तो किसी ने कवर नहीं करी, राइट. दिस टर्म इज नॉट कवर्ड बाय एनीवन एल्स, राइट. लेकिन इस टर्म को कवर करने के लिए हमारे पास दो ऑप्शन है. या तो हम इस टर्म को इस वाले प्राइम इम्प्लीकेंट से कवर कर लें या फिर इस टर्म को हम इस वाले प्राइम इम्प्लीकेंट से कवर करें. इन आवर सॉल्यूशन ऑब्वियसली दिस टर्म शुड बी देयर बट वी हैव टू चॉइसेस to cover this term. So this is also a prime implicant, this is also a prime implicant और हमारे पास दो choices हैं. तो ना तो ये जो prime implicant है ये essential है because ये कुछ ऐसा cover नहीं कर रहा जिसको कोई और cover नहीं कर रहे. It is not covering any term which is not covered by others, right? As well it is not covering any term which is not covered by others. तो obviously ये जो दोनों हैं ये आपके पास essential नहीं है but at the same time they are not redundant because इन दोनों में से अगर आप किसी एक को ऐड नहीं करोगे then your solution will not be complete, then you will miss out this term. आप इस term को मिस करेंगे. So basically in your solution out of these two at only one should be there. या तो आप अपने solution में इस वाले को consider करेंगे या फिर आप अपने solution में इस वाले prime implicant को consider करेंगे. Okay, I'll show you with some examples. Once I will take a few examples, then you will be able to understand. Okay, now let us look at this example here. So I've already taken this example before. एक ये example हम लोग पहले भी देख चुके हैं. Now in this example you can see that we have four essential prime implicants. So 1, 2, 3 and 4. All of these four are representing essential prime implicant. And this subgroup, it is just a prime implicant but it is not essential. ये वाला जो सबक्यूब है बड़े वाला जो सबसे बड़ा सबक्यूब यहाँ पर पॉसिबल है, इट इज जस्ट अ प्राइम इम्प्लीकेंट बट इट इज नॉट एसेंशियल. सो दिस प्राइम इम्प्लीकेंट should not come in the solution because if you will add this prime implicant then your solution will not be minimized. ठीक है. अब देखो इसको ऐड करने का मतलब क्यों नहीं मतलब why we are not even adding this. We are not even adding this because it is not covering anything that is not covered by others. इसके पास जितनी भी चीजें हैं वो सभी दूसरे प्राइम इम्प्लीकेंट्स कवर कर रहे हैं. इट इज नॉट कवरिंग एनी स्पेशल मिनटर्म, करेक्ट. सो देयर इज नो पॉइंट ऑफ एडिंग दिस वन. इसको हमें ऐड करने की कोई भी जरूरत नहीं है. सो इन योर सॉल्यूशन दिस शुड नॉट कम. सो ओनली 4 मिनटर्म्स विल बी देयर इन द सॉल्यूशंस. वी विल नॉट बी हैविंग 5 मिनटर्म्स. ओके, नाउ कंसीडर दिस वन आल्सो. अब यहां पर क्या है देखो, दिस इज अ प्राइम इम्प्लीकेंट, क्लियर. This is also a prime implicant. This is also a prime implicant. This is also a prime implicant. This is also a prime implicant as well as this is also a prime implicant. So here you can see there are a lot of prime implicants but we do not have an essential prime implicant. यहाँ पर बहुत सारे prime implicant है लेकिन यहाँ पर कोई भी essential prime implicant नहीं है. Why we are not having any essential prime implicant? Because every term is covered by two implicants. हर एक जो term है जैसे for example this is a term, so every term is covered by two prime implicants. हर एक term जो है दो prime implicant उसको cover कर रहा है. ठीक है. Now we can say that there are no essential prime implicant here. यहाँ पर कोई भी essential prime implicant नहीं है, right? And there are no redundant prime implicants also. यहाँ पर कोई redundant prime implicant भी नहीं है. We do not have a redundant prime implicant as well as we also do not have an essential prime implicant. ना तो हमारे पास redundant है और ना ही essential है. If you do not have a redundant and if you do not have an essential, please try to answer what kind of prime implicant we have. हमारे पास किस तरह का implicant है? What kind of implicant we have? We have selective prime implicant. यहाँ पर हमारे पास selective prime implicant है. Now, what can I say? How can I say it is selective? हम इसको selective क्यों बोल सकते हैं? देखो, why we call it as a selective? If we select this prime implicant, then I do not have to select this one. Then I can select this one because ये जो term है वो हम already इसको cover कर चुके हैं. So if we select this one, then I can select this one, and then I can select this one. So basically we can have only 3 minterms. हमारे पास यहाँ पर जो हमारा solution होगा उसके अंदर 3 minterms ही होंगी. We only need 3 minterms here. We can have this as a solution. ये हमारे पास solution में हो सकता है. और what I can do is I can select this subcube. मैं इस subcube को select कर सकता हूँ. I can select this subcube and I can select this subcube. So basically just by using 3 minterms I will be able to get the solution. So basically whenever I say that we have a selective prime implicant, it means that prime implicant is neither essential, ना तो वो essential है, and at the same time it is nor redundant, ना तो वो essential है और ना ही वो redundant है. Then we call it as a selective prime implicant. So in this case we have a selective prime implicant. There are 6 selective prime implicants. There are 6 prime implicants. There are 0 essential prime implicant. There are 0 redundant prime implicant. ठीक है. So for this given problem there are 2 different solutions are available. यहाँ पर 2 अलग-अलग solutions available है. Now this kind of problem can also be solved by using prime implicant chart. इस तरह का जो problem है, sometimes it is very common that you guys or people make mistake in this kind of problems. Therefore we need something called as prime implicant chart. So I will explain, I will cover what is a prime implicant chart. Lot of videos will be coming. तो मैं prime implicant chart को काफी अच्छे से cover करूँगा. You will understand what I'm trying to say. Okay, so let us look at this example here. Again in this example you can see there are no essential prime implicant. इस example में कोई भी essential prime implicant नहीं है. There are no essential prime implicant. There are no redundant prime implicant. All the implicants that we have, all of these implicants are selective prime implicant. जितने भी prime implicant है ये selective है. So number of implicants here, कितने implicants हैं यहाँ पर? I think yes, there are 2 essential prime implicant. Because I think I have not seen the figure, मैंने figure को नहीं देखा था, so I made the decision without even seeing the figure. If we have something like this, अगर यहाँ पर आपके पास एक 1 होता, if you have a 1 here, then you could have seen कि यहाँ पर कोई भी essential prime implicant नहीं है. So because we do not have a 1 here, that is why we do not. This is not an essential prime implicant. Okay. Now, anyways, so here we have 2 essential prime implicant. We have 4 selective prime implicant. So any of your solution, in any of their solution, both of these essential prime implicant should be there. जो भी आप solution propose करेंगे, in any solution that you propose, essential prime implicant should always be there. आप कुछ भी solution propose करेंगे, वहाँ पर essential prime implicant होंगे ही होंगे. Now in this case, you can see 1 and 4. 1 and 4 both are essential prime implicant. So here in both the solutions 1 and 4 are there. But for all the selective prime implicant we have choices. Either this can be there or this will not be there. If this is there then I do not need this one. तो मुझे इसकी ज़रूरत नहीं है. Then I can only cover this one, right? So for all the selective prime implicants we have choices. And according to the choices you can identify how many unique solutions are possible. या तो वहाँ पर 2 होगा या फिर वहाँ पर 5 होगा, या तो वहाँ पर 3 होगा या फिर वहाँ पर 6 होगा. So we have choices. Okay. I will also explain you with the help of a prime implicant chart. जो हमारा prime implicant chart है, मैं उसके साथ एक क्वेश्चन को आपको explain करूँगा. Don't worry. Okay, so let me do one thing. Maybe I can also try and explain this previous example. I'll do the next video. In this next video, I'll try to explain this one using a prime implicant chart. Then you will understand why we do not need this as a solution. ठीक है? So let me pause the video right here and I'll make the next video. Previous video में मैंने आपको बताया था, I told you the previous video that what are prime implicants, essential prime implicants, selective prime implicants, and redundant prime implicants. And in that previous video, I've also shown you a K-map like this. And in that K-map, I told you that we do not have any essential prime implicant. आपके पास कोई भी essential prime implicant नहीं है. You do not have any essential prime implicant, but rather all the implicants that are present in that diagram, all of those implicants are selective prime implicants. Okay, so here in this example, let us look at it in more details. Okay, now in this case we are going to have so many subcubes. Let me also mark out all the subcubes with you. So this is one of the subcube, correct? This is another subcube, this is another subcube, as well as we can also have this as a subcube. आपके पास ये भी एक subcube हो सकता है. But apart of this, you also have other subcubes. इसके अलावा और भी subcubes आपके पास possible है. You can combine this one with this one. You can combine this one with this one. हम इन दोनों को combine कर सकते हैं. You can combine these two. So you can clearly see that in this diagram we do not have any essential prime implicant. Now sometimes to solve this kind of questions, it becomes very tricky how to solve it. But there's one method which is very trustable method, and using that method you can easily solve such kind of problems, and that method is called as prime implicant chart. In this video I'm going to tell you about what is a prime implicant chart. So the topic that we have here is prime implicant chart. Okay, so basically we are trying to identify what are the implicates that I can use in my solution. So to do that, first of all, I have to mention all of these numbers, or I can say all of these subcube. I have to make a table here. So I'm going to make the table in this manner. This is the table. So here we have total of 16 values. So we have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 and 16. So basically the maximum value here is 15 only, because we have 0 to 15, so we do not have 16. Okay, and now let us try to analyze what each of these subcubes is representing. ये हर एक subcube क्या क्या represent कर रहा है, and how many subcubes do we have. So this is representing A complement, B complement, A complement B, AB and AB complement. This one is C complement, D complement, C complement D, CD and CD complement. Okay, so we will take this horizontal subcube. We'll start with this horizontal subcube. What this horizontal subcube is presenting? It is representing A complement, B complement and C complement. ये क्या represent कर रहा है? A complement, B complement and C complement. Then what this horizontal subcube is representing? It is representing A complement, B and D. This horizontal subcube is representing A, B and C. And this horizontal subcube here, it is representing A, B complement and D complement. Okay, so I've taken 4 of them now. Now let us find out the other 4. जो दूसरे 4 हैं आपके पास यहाँ पर. Let us try to analyze them also. ठीक है. So this is the green one. So I think I do not have a space there. Let me write it here. So this is the green one. So this green one is representing C complement, D complement and B complement. Okay. So this green one here, it is representing C complement, D and A complement. This green one here, it is representing C, D and B. And this green one here, ये जो green वाला है, this one is representing C, D complement and we have A. Okay, so you have to make all of these values properly, right? Because there are many times we do a lot of mistakes here. ये जो diagram है थोड़ा सा confusing है, so sometimes while solving such kind of questions we make mistakes. So obviously I'm not such exception. Maybe I've also made a mistake, but we will try to analyze all of the. If I've done any mistake, I'll try to analyze. So let us first try to understand what the concept says. So here I try to identify what are all the implicants. वो सभी implicants क्या है? Now I'm going to write all of these implicants here. So let us take each of these implicants one by one. So we have the implicants which is A complement, B complement, C complement. We have A complement, B and D. We have A, B and C. We have A, B complement and D complement. We have A complement, D and C complementation, and then we have C, D and B, or you can say B, C, D. You can say it as a B, C and D. Then we have A, C and D complementation, and then we have B complement, C complement and D complement. So I have written all of them like this. Okay. And now I'm going to just put some lines here so that it will be easier for me to understand, ताकि मुझे थोड़ा सा समझना आसान हो जाए. For that reason I'm going to divide this into tables, or you can say rows and columns like this, so that it will become very easy for me to fill this table. इस टेबल को भरना मेरे लिए आसान हो जाए, इस वजह से मैंने इनको इस तरीके से डिवाइड कर लिया है. Okay. Now let us look at each one of them. So first one is A complement, B complement, C complement. So this A complement, B complement, C complement is covering the term 0 and 1. So wherever we have 0 and 1, I'm going to put a cross mark here. I'm going to put a cross mark here as well as a cross mark here. Then I will take the next one. तो जो अगला आपके पास है, this is B, C, D. ठीक है, I think A complement BD. So we have A complement BD. So this A complement BD is covering 5 and 7. So wherever I have 5 and 7, I'm going to put a cross mark over there. Then we have ABC. So this ABC is covering 5, 15 and 14. So ABC is covering 15 and 14. So I'm going to put a cross mark. ठीक है. Then we have A, B complement and D complement. And this A, B complement, D complement, it is covering the term 8 and 10. तो ये जो है 8 को और 10 को cover कर रहा है. Then we have A, B complement, D complement. So this is the term which is I think where is this term? Let me check again. We have A, B complement and D complement. Yeah, I think this is the A, B complement and D complement, I think. So I've already covered it. So ABC, yeah, so I think I've made a mistake here. तो यहाँ पर मैं थोड़ा सा mistake किया है. This A complement, B complement, D complement is covering 8 and 10. So this is here. तो 8 और 10 जो है वो कुछ यहाँ पर है. 8 is here as well as 10 is here. Next one is A complement, D, C complement, right? A complement, D, C complement, and it is covering C complement D. ठीक है, तो ये क्या cover कर रहा है? This is 1 and 5. तो ये cover कर रहा है हमारे पास 1 को और 5 को. उसके बाद we have B, C, D. तो जो आपके पास B, C, D है, where is B, C, D? So we have let me look at. So this is B, C, D. So this B, C, D is covering the term 7 and 15. तो जो B, C, D है वो 7 को और 15 को cover कर रहा है. It is covering 7 and 15. Then we have A, C, D complement. So this A, C, D complement is covering the term 14 and 10. So ACD complement is covering 14 as well as it is also covering the term 10. And then the last one here, which is B complement, C complement, D complement, it is covering 0 and 8. It is covering 0 as well as it is covering 8. ठीक है. So this chart is called as your prime implicant chart. इस chart को हम बोलते हैं prime implicant chart. I think some of the portion is not visible. Let me try if I can make it visible. मैं आपको थोड़ा सा कोशिश करता हूँ. Just give me a second. So I believe this chart is now visible. Let us look at each of these one. देखो basically what I'm trying to say is my aim is I want to cover all the terms here. जो जहाँ पर हमारे पास 1 है, I want to cover all of these ones. मुझे इन सभी 1 को cover करना है. That means in my solution equation I have to identify which one should I add. So जैसे here if I add this in my solution equation, अगर मैं अपने solution equation में a complement, b complement और c complement को add करता हूँ, if I add this in my solution equation, then I will cover the term 0 as well as I will cover the term 1. मैं 0 और 1 को cover कर लूँगा. Okay. Now if I add the term a complement bd, अगर मैं a complement bd को अपने solution में add करता हूँ, if I add a complement bd, then I will be able to cover the term 5 as well as I will be able to cover the term 7. मैं 5 और 7 को cover कर लूँगा. Okay. And then if I add this term which is a b complement d complement in my solution, that is a b complement and d complement in my solution, then using this term I will be able to cover 8 as well as I will be able to cover 9. मैं यहाँ से 8 और 9 को भी cover कर लूँगा. And then if I add this one which is ABC in my solution, अगर मैं ABC को अपने solution में add करता हूँ, then I will be able to cover 14 and 15, right? So that means in my solution I needed only 4 minterms, and with the help of all of these 4 minterms I have covered every term in this K map. सिर्फ इन 4 minterms के help से मैंने इस K map के अंदर सभी terms को cover कर लिया है. I've covered every term in this K map. So because I've covered every term here, I do not really have to add any of this. मुझे इनको किसी में से किसी को भी add करने की ज़रूरत नहीं है. Why I do not have to add them? Because they are not covering any term which is not covered by them. इन्होंने ही सब कुछ को cover कर लिया, so we do not have to add them. Okay? In the same way you can choose. If I do not use this term, अगर मैं इस term को use नहीं करता, then I might be having a choice for the other term. मेरे पास दूसरी term को use करने के लिए भी कोई choice हो सकती है. So for such kind of questions, more than one solution equations are possible. इस तरह के questions में एक से ज़्यादा solution equations जो हैं वो possible हैं. Okay? So for such kind of questions, you can also try and make prime implicant chart. अब यहाँ पर prime implicant chart को भी use कर सकते हैं. Now after all the things that we have covered so far, come back to my first slide. Come back to my beginning slide. So in the beginning slide, I told you what is a K map. So in your K map, you are representing all the minterms. तो जितने भी minterms हैं, we represent all of these minterms with the help of 1, and we represent all the max terms with the help of 0. तो जितने भी आपके minterm हैं उनको हम 1 से represent करते हैं, जितने भी आपके max terms हैं उनको हम 0 से represent करते हैं. So the same concept which is valid on minterms, similar concept is also valid on max term, but the only difference here is in case of max term, wherever we have 0, 0, we do not write them in a complemented form, but rather we write them in an uncomplemented form. I will take that in example. I will take a few examples where I will also try to find the max terms, and I will also try to find some of the minterms. Okay. So I told you that you can skip this PPT. Now look at this PPT. ये PPT क्या represent कर रही है? So this PPT is representing that if we have a K map like this, and if you fold this K map in a, let me show you with the help of an example. Okay. So let us assume this is your K map. ये आपका K map है. So what I can do is I can fold this K map in the form of a circle like this. मैं इस K map को इस तरीके से circle में fold कर सकता हूँ, and then I can combine all the end of the circle here in the K map. तो हर एक जो circle का जो सभी end है मैं उसको कुछ इस तरीके से combine कर सकता हूँ. Okay. Then I mean to say in this manner I can do. I have a K map. I can fold this K map in the form of cylinder, and then I can combine the ends of the K map in this manner, and then this K map will look something like this. So it is looking like a donut. किस तरह से दिख रहा है ये एक donut की तरह से दिख रहा है, right? So when you do it something like this, then all of your corners, ये जितने भी आपके corner है, all of your corners will come together, and when these corners will come together, if the values of these corners, जैसे यहाँ पर if the value of this corner is 1, let me just write it down here. So if the value of this corner is 1, here we have a 1, here we have a 1, as well as here also we have a 1, then we can combine all of these ones together because they will make a subcube like this. वो यहाँ पर इस तरीके से एक subcube को form करेगा, it will make a subcube like this. That is why I can combine all of these 4 corners. इसी वजह से मैं K map में इन सभी corners को भी combine कर सकता हूँ. Okay, I hope that you understood this part. Let us look at the next video. In the next video, I will try to solve the K maps for the max terms. In the previous examples, we have seen how to find the SOP, or you can say sum of product expressions. In this example, I'm going to look at what is product of sum, or you can say the POS expression. In this product of sum, as you can see, this is a function which is a 3 variable function. So obviously I'm going to need a 3 variable k-map. So by mistake I'm using a 4 variable k-map here, but this is a 3 variable k-map only. Okay, first I will explain you how the concept works, and then maybe we can also use a 3 variable k-map to solve this one. Okay, let me first explain the concept, then I think you will be able to understand it clearly. So what do you really mean by a product sum term here? यहाँ पर ये जो expressions हैं, these are product of sum expressions. What do you really mean by this product, this sum term? ये sum term का मतलब क्या है? This sum term means every sum term will assume a value 0 for exactly one combination of input variable. सिर्फ एक ही combination of input variable के लिए इसकी जो value है वो 0 होगी, otherwise for all other values it will assume a value 1. For example, here if I pass a value 0 to A, 0 to B and 1 to C, then only this will have a value 0. Here if I pass a value 0, 1 and 1, then only it will be having a value 0. Here again it is, if I pass a value 1, 1 and 1, this is 1, 0 and 0, this is 0, 0 and 0. In all of these locations they are having a value as 0. Okay, so obviously I'm going to draw a 3 variable k-map here, so I'm only going to need this half part of this k-map. हमें सिर्फ इतने से part की ज़रूरत है because it is only a 3 variable k-map. Fine. And here this is representing a variable A and this is representing a variable B and C. Correct? So this is A complement and A. This is B complement C complement, B complement C, BC and BC complementation. But if you show the same terminologies, for the sum term, then it will be different. Because in a sum term, if I just draw the same k-map, आप sum term में सभी इस k-map को exactly same k-map को आप किस तरीके से present करेंगे? How are you going to represent the same k-map here? So wherever I have complement, I'm going to write in a non-complemented form. जहाँ पर भी complement है हम उसको non-complemented form में represent करेंगे. And wherever we have a plus, we are going to replace the plus with dot. So here I'm going to have A and here I'm going to have A complement. So this term will be B plus C. This will be B plus C complement. This will be B complement plus C complement, and this term will be B complement plus C. This is for variable A and the variable B and C. Okay. So both the k-maps are exactly representing the same thing. दोनों जो k-map है वो एक ही चीज को represent कर रहे हैं. Even if I try to give numbers here, I can also give the same number here, which is 0, 1, 2, 3, 4, 5, 6, 7. The same number can be represented here 0, 1, 2, 3, 4, 5, 6 and 7. So numbering is exactly the same. Okay. Now let us look at each of these combinations one by one. So this combination is representing 0, 0, 1. 0, 0, 1 means we have a minterm which is, we have a term which is 1. इसकी जो value है, this value is 0, 0, 1. So 0, 0, 1 in decimal is only 1. ठीक है, that means here on the location 1, here we are going to have a value 0. तो यहाँ पर आपके पास value 0 है. You can also represent the same. Here आप यहाँ पर भी इसको represent कर सकते हैं. If I have 0, 1, 1, 0, 1, 1 means 3. So in the third location we are having a 0 value. If I say 1, 1, 1, that means 7. So here we have a 0. Then we have 1, 0, 0. 1, 0, 0 means 4. So here we have a 0. And then we have 0, 0, 0. That means this location. So here you can see in these locations we are having a value 0. And in all other locations we are having a value 1. So here a value 1 will be there. This is 1, this is 1, this is 1, this is 1 and this is 1. So even if you are trying to draw the k-map in this way, or even if you are trying to draw the k-map in this way, both the things are same. So I'm showing you two different k-maps here because I wanted to show you that you can use even this kind of terminology. You can number, or you can give naming to the cell in this way, or you can also use this manner. आप किसी भी तरीके से इसको use कर सकते हैं. You can use it in any way you want. Now there's something more interesting here. Something more interesting. Let me do one thing. Let me use this K-map to find SOP expression, and let me use this K-map to find POS expression. Even though from this K-map also you can find POS. आप यहाँ से भी product of some expression को निकाल सकते हैं. You can use this one also, as well as you can also use this one. You can use any one of them. But for simplicity purpose right now, I'm using this K-map to find sum of product expression, and I'm using this K-map to find product of sum expression. So in this case, I can make a subcube here, as well as I can make this as a subcube. So this is representing a prime implicant, as well as this is also representing a prime implicant. Why? It cannot be combined with anyone else, right? And this prime implicant is trivial. So simply I can just say it is an implicant. Okay. So this subcube is representing BC complement, and this subcube here, it is representing AB complement C. ठीक है, AB complement C. So what is your minterm? I mean, what is your SOP expression? So your SOP expression for this will be AB complement C plus BC complement. AB complement C plus BC complement. Okay. Now let us look at the next one here. Let us look at this one. So here you can see this is representing your product of sum. ये कौन सी expression को represent कर रहा है यहाँ पर? Product of sum expression. Again, we can also make subcubes in the same manner. So I can have this as a subcube. I can have this as a subcube. Now I can combine this 0 with this one, or this 0 with this one. मैं इसको किसी के साथ भी combine कर सकता हूँ. So let us suppose that for simplicity purpose, I am combining this 0 with this one. ठीक है? Clear? Is it clear with you guys? Right? So if it is clear, now you can see I can write this as B plus C. मैं इसको B plus C से represent कर सकता हूँ. I can write this one as B complement plus C complement, and I can write this one as your A plus C complement. Therefore, your product of sum expression will be B plus C dot B complement plus C complement dot A plus C complement. So this is representing your product of sum, POS expression. Is it clear? इतना आप सभी के साथ clear है? Please let me know if there's any doubt. I'll be happy to answer all of your doubts. So your correct answer here is your product of sum expression is B plus C dot B complement plus C complement dot A plus C complementation. Okay? Fine. Now let us take the next one. So again here also this is the same question, but this time it is a 4 variable K map. We have A, B, C, D. तो ये आपका 4 variable K map है, and here they are giving us the max terms. तो हमारे पास max terms given है. So let me do one thing. Instead of writing the max term here, I'm going to solve it by using the minterm representation. ठीक है? Let me show you what I'm trying to say. Let me show you what I'm trying to say here. So this is, I'm so sorry. Yeah. So this is the variable AB, and this is the variable CD. ठीक है? So the numberings are 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay? So this is representing A complement, B complement, A complement B, AB, and A B complement. This one is representing C complement, D complement, C complement D, CD, and this is C D complementation. Okay? So again you can see I have not written C complement plus D here. मैं यहाँ पर जो मेरे पास already expressions थी, I already knew the K map, तो मैं same K map को यहाँ पर use कर रहा हूँ. I'm not doing anything special here. Okay? Now here in these locations we are having a value 0. So here we have a 0, here we have a 0, here we have a 0, and then here we have a 0. This is also having a 0, and this is also having a 0, this is having a 0, and this is having a 0. So in these locations we are having a 0. How many locations are there? These are total 8 locations. 1 2 3 4 5 6 7 8. So in 8 locations you are having a value 0, and then in how many locations you are having a value 1? So 1 1 1 1 1 1 1 1. These are the locations where you are having a value 1. So obviously from the same K map you can find SOP expression as well as you can also find POS expression. I'll show you the same with this example. मैं आपको दोनों चीजें यहाँ से दिखाऊंगा. So first of all, let us look at what are the subcubes that are possible. Okay, so I can make this as a subcube. ये आपका एक काफी बड़ा subcube है. I can make this as a subcube, second one. I can make this as a subcube, third one, as well as I can also make this as a subcube, which is the fourth one. ठीक है, तो आपके पास यहाँ पर SOP expressions के लिए 4 subcube बनेंगे. There will be 4 subcubes. Okay, and this subcube is representing A complement B. This subcube here, it is representing C complement D and A complementation. This subcube here, it is representing your A, C, D complement, and this subcube here, it is representing your A, B complement and C, right? So what is your SOP expression here? तो यहाँ पर जो आपकी SOP expression है वो क्या रहेगी? SOP expression will be A complement B plus A C D complement plus A B complement C plus A complement C complement D. तो ये जो है आपकी SOP expression रहेगी. I hope, I think it is not visible. तो जो लास्ट वाला पोर्शन है वो visible नहीं है. Let me write it down again. Okay. So till this part it is visible. ठीक है, so the last one here, the last one was A complement, C complement and D. तो ये बनी आपकी SOP expression. Now let us look at what is the POS or product of sum expression. तो product of sum expression में we will look at what are the subcubes. ठीक है, तो क्या क्या subcubes यहाँ पर possible है. Let us look at all of these subcubes one by one. So this is a subcube that is possible, and then this can also be used as a subcube. This can also be used as a subcube. So these are 3 subcubes. Now for this 0 we have 2 choices. Either you can combine this 0 with this one, or you can combine this 0 with this one. आप इसको किसी के साथ भी combine कर सकते हैं. So let us assume for simplicity purpose I am combining this 0 with this one. मैं इसको इसके साथ combine कर रहा हूँ. Okay, clear? Fine. Now by looking at this, let us look at what is the expression I am going to get. So this subcube here, देखो here something interesting will be there. कुछ interesting होगा, कुछ अलग होगा, because whenever I am writing SOP, so SOP I have to take it as A complement dot B. But whenever I am writing POS means this will become opposite. It will be A plus B, right? तो ये क्या बनेगा आपके पास? This will become A plus B, and even D is not changing, so it is A plus B plus D. And what is this one? तो यहाँ पर क्या है? So this is A complement dot B complement, so this will be changed at A complement का A हो जाएगा, so this will be A plus B, and here C and C is there, right? So I can say C complementation. ठीक है, in the same way I can also do something for this one also. तो यहाँ पर क्या है आपके पास? This is representing D is not changing as well as AB is not changing, so this is A complement plus B complement plus D complement. So इसके अंदर this one here, so for this one B is changing as well as D is changing, so this will be A complement plus C. तो ये जो है ये बनेगा आपके पास A complement plus C. So by looking at this I can write what is my product of sum expression. तो आपकी product of sum expression क्या निकलेगी? So your POS expression will be A plus B plus C complement dot A plus B plus D dot A complement plus B complement plus D complement dot A complement plus C. So this is representing your product of sum expression. I hope it is fine. Just have a look at it and let me know if there is any doubt. I think it should be clear. Now these are a few questions. These questions are for your understanding. Please do one thing, you can pause the video and please solve all of these questions for practice purpose, and the solution of all of these questions are given on the next slide. So this slide is embedded in the chat window, or you can say in the about video of this about section of this video. You can also find the same slide from there. अब वहाँ से इस slide को भी ले सकते हैं. Okay. Now let us look at what are incompletely specified functions. तो हमारे पास कुछ ऐसी conditions होती हैं, there are few conditions which are called as don't care conditions. हमारे पास कुछ ऐसी conditions होती है जिनको हम लोग don't care condition से represent करते हैं. Okay. Now what is the use of this don't care? देखो, let us assume sometimes you are not going to use a few combination. आपको उन combination की क्या values होती है उससे आपको कोई फर्क नहीं पड़ता, तो उस conditions को हम लोग don't care conditions से treat करते हैं. ठीक है, उन conditions को किसे treat करते हैं हम लोग? don't care condition से, right? जैसे for example, here we have a 3 variable function. So this 3 variable function, it will be having a total 8 combinations. So I'm saying these 2 combinations are don't care. Don't care means these combination can take any value whatsoever, doesn't matter. For me it doesn't matter. So this can take a value of 0 or it can take a value 1. Now such kind of conditions is called as your don't care condition. इस तरह की conditions को हम लोग don't care condition से treat करते हैं. Okay, and these don't care conditions you can either use D to represent a don't care condition, or you can use this cross to represent a don't care condition. So let us look at how to solve a don't care condition. तो सबसे पहले let us try to analyze this one. So let us do the function f here. So this is the variable a, this is the variable b and c. So it is representing a complement and it is representing a. This is representing b complement c complement, b complement c, and this is b c complement. ठीक है. I think I've made a mistake here. So here one more column should be there. So this is representing BC and this is BC complementation. ठीक है. Now if you take the first one here, in the first one there are minterms. ठीक है. So minterms are 0, 2 and 4. I can number them. I can say this is 0, 1, 2, 3, 4, 5, 6 and 7. So that means according to this, at the location 0 we have a 1, at the location 2 we have a 1, and the location 4 we have a 1. ठीक है. So you can clearly see when I'm writing small m or if I'm representing summation, या तो मैं summation को represent करूँ या फिर मैं small m को use करूँ. If I'm using small m or if I'm using summation, then it is called as a minterm. If I'm using pi or if I'm using a capital M, that means representing a max term. So here we have 2 don't care condition. We have a condition 1 and 5. I mean here in this location 1 we have a don't care, and here also in 5 we are having a don't care. And in all other locations we are going to have a value 0. In सभी locations पर मेरे पास एक value है 0. Now what is the significance of this don't care? You can combine these don't care according to your convenience. You can say this don't care is having a value 0, you can give it a value 1 according to your convenience. आप अपनी मर्जी से, अपनी convenience से don't care को कोई भी value assign कर सकते हैं. Only thing is you want to minimize the number of literals in your solution expression. आप वहाँ पर सिर्फ number of literals को ही minimize करना चाहते हैं. So let us assume we have this K map. Now in this K map I can combine this don't care with these ones. I can combine this one with this one. If I do something like this, then this entire box, or you can say subcube, is representing B complementation, and this box here, it is representing A complementation, C complementation. So therefore your SOP expression will be B complementation plus A complementation, C complementation. SOP expression जो है वो आपकी कुछ इस तरीके से रहेगी. This will be your SOP expression. And then we have POS expression, that is product of sum expression. अब देखो product of sum expression में again I can use these don't care and I can assume that these don't cares are having a value 0, so I can combine them with these 0. देखो main aim क्या है? The main aim is that there should be minimum number of literals in SOP as well as POS. आपके पास SOP और POS दोनों में minimum number of literals होने चाहिए. So I can combine this don't care with this and I can make these as a subcube. So this subcube here, ये वाला जो subcube है, this subcube is representing your A complementation, and this subcube here, this is representing your C complementation. Therefore, your POS expression will be A complementation dot C complementation. So this will be your product of sum expression. So again, as I'm saying, I want to assign any value to the don't care combination in such a way that our solution equation, or you can say your end solution, can be minimized. आपका जो end solution है उसको minimize किया जा सके. Okay. So you can do the second part by yourself. आप इसको खुद से कर सकते हैं. Let me do this one. So here you can see we are having some minterms. Locations are 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 and 15. And this function is assuming a value 1 in this location 1, 3 and 7 and 11 and 15. Okay, and we have don't care conditions as 0 to 4. So here we have a don't care condition, here we have a don't care condition, as well as here we have a don't care condition, and this is representing the function AB and CD. This is C complement D complement, C complement D, CD and CD complement. This is A complement B complement, A complement B, AB and AB complementation. ठीक है, and in all other locations we are having a value 0. बाकी सभी locations पर value 0 है. 0, 0, 0, 0, 0, 0, 0 and 0. These are the values. So first of all, let us try to identify what is the SOP expression. So as I said, you can combine don't care conditions. So I can combine this don't care with this subcube, and here we are also having this subcube. तो आपके पास दो subcube बने हैं. So this subcube is representing A complementation, B complementation, plus this subcube here, it is representing C, D. तो आपके पास जो SOP expression, it is such a small SOP expression. Just because we have a don't care condition, we can easily minimize the SOP expression here. In the same way, I can also combine these don't care conditions with product of some expressions. So I can make one subcube this. So this, not this. So I can make a subcube in this manner. I can combine these elements to create a subcube. हम इसको यहाँ से subcube बना सकते हैं. I want to make as big subcubes as possible. I can combine these two for a subcube. मैं दोनों को subcube से combine कर सकता हूँ. I can combine this one with this one, as well as I can combine this one, or can say this one, not this smaller one. I want to take a bigger one, so I can combine this one with this one. Oh, I'm so sorry. I think by mistake I've done it. So let me make them again. Okay. So I can make this as a subcube. देखो हमें क्या करना है? We want to have as big subcube as possible. जितने बड़े हो सके उतना अच्छा है. Okay. So मैं इनको इस तरीके से भी combine कर सकता हूँ. ठीक है? And at the same time, I can combine this 0 with this don't care and 0, and then I can combine this one here. तो इस तरीके से हमारे पास कुछ subcubes जो है वो यहाँ पर possible है. ठीक है? Now you can clearly see how interesting it becomes. कितना interesting हो जाता है, because the expression can be minimized. So this one here, ये जो आपका subcube है, here D complement is not changing, as well as here A is not changing. So this is representing A complement plus D. ठीक है? In the same way, if I take this subcube, अगर मैं इसको लूँगा, now in this case, in this subcube, here A is not changing, as well as C complement is not changing. So it is A complement plus C. Okay? And if I take this green one as subcube, अगर मैं इस green वाले को subcube लेता हूँ, if I take this green one, so for this green one, we have D as well as B complement. So it is B complement plus D. ठीक है? And then we have this one. ये वाला जो subcube है, this subcube is representing B complement plus C. This is B complement plus C. So this is the product of some expression. यहाँ से कुछ इस तरीके से आपके पास product of some expression आ सकती है. So I believe I have done all of them. कितने subcube है? 1, 2, 3, 4. 4 here. I think only 4 are there. So only 4 subcubes are there, and in this way I can give product of some expression. आई होप यू अंडरस्टूड व्हाट इज द यूज ऑफ डोंट केयर. हम डोंट केयर को यूज कर सकते हैं टू मिनिमाइज आवर एक्सप्रेशंस. हम अपनी एक्सप्रेशंस को मिनिमाइज करने के लिए यहाँ पर डोंट केयर का यूज कर सकते हैं. इट इज़ सच एन ईजी प्रॉब्लम. इतना आसान तरीका है. इस तरीके से आपकी जो प्रॉब्लम्स हैं वो काफ़ी ईजी हो जाएंगी. ठीक है, आपकी जो प्रॉब्लम्स हैं, जो क्वेश्चंस आप सॉल्व कर रहे हैं, उनको सॉल्व करना आप सभी के लिए बहुत ज़्यादा आसान हो जाएगा. ठीक है, सो लेट अस मूव फॉरवर्ड हियर. सो यहाँ पर आप सॉल्यूशन देख सकते हैं. यू कैन सी द सॉल्यूशंस हियर एंड यू कैन ट्राई टू सी कि आप क्या क्या सबस्क्रिप्ट्स यहाँ पर बना सकते हैं. एंड दिस इज फॉर यू, दिस इज फॉर योर प्रैक्टिस. आप इसको अपनी प्रैक्टिस के लिए ले सकते हैं. एंड यू कैन सी कि सॉल्यूशंस इज ऑल्सो प्रेजेंट. आप चाहें तो वीडियो को पॉज करके सॉल्यूशन को वेरीफाई कर सकते हैं. यू कैन वेरीफाई द सॉल्यूशन बाय पॉजिंग द वीडियो ऑल्सो. सो टेक दिस वन फॉर प्रैक्टिस एंड ट्राई टू अंडरस्टैंड द क्वेश्चन कि कैसे सॉल्व करना है. टेक ऑल ऑफ देम फॉर प्रैक्टिस. ये सभी आपकी प्रैक्टिस के लिए हैं. बिकॉज एज मच एज यू प्रैक्टिस इज द की. प्रैक्टिस सबसे इंपॉर्टेंट है. प्रैक्टिस की है, तो प्रैक्टिस आपको जरूर करनी है. Practice is very very important here. Okay, and this is the theory part. So this theory part is just representing what is the rule for simplifying the logic function using K-map. आप K-map से logic function को कैसे simplify कर सकते हैं. Whatever we have covered so far, this is a summary of that. तो ये सिर्फ उसकी summary है. ठीक है, I hope you understood this one. Now in the next video we are going to look at what's a variable entrant map. अगले वीडियो में हम variable entrant map के बारे में डिस्कस करेंगे. In this video, let us discuss about the variable entrant maps. इस वीडियो में हम variable entrant map के बारे में डिस्कस करेंगे. And what exactly is the variable entrant map? Variable entrant map का meaning क्या है? देखो, sometimes it can happen that you are having a bigger function. Maybe you are having a 5 variable function. So solving that 5 variable function becomes very difficult because the K-map for the 5 variable function will be having a total of 32 cells. 5 variable function में 32 cells होंगे. And solving that K-map will be very very hard, very very difficult. Okay, so what you can do is you can convert that 5 variable K-map to a 4 variable K-map, and then you can solve this 4 variable K-map. Solving the 4 variable K-map will be very very easy. 4 variable K-map को solve करना बहुत ही आसान हो जाएगा. In the same way, you can also convert a 5 variable K-map to a 3 variable K-map. आप 5 variable K-map को 3 variable K-map में भी convert कर सकते हैं. And solving that 3 variable K-map will also be very very easy. Okay, so we will discuss the technique कि इसको कैसे convert करना है. We will discuss the technique one by one, and then I think you will be able to understand. So let's first look at how can you create a variable entrant map. हम पहले variable entrant map को कैसे बना सकते हैं. So here this is representing a 3 variable function. So you know, to solve a 3 variable function we need a K-map which will be having 8 cells, but I can also represent this entire 3 variable function with the help of only 2 variable K-map. कैसे कर सकते हैं? Let us look at this one. So solving it is very very easy. ठीक है, इसको किसी भी आप कोई भी 2 variables को choose कर लीजिए. Here I can say that I want A and B to be present as a variable. I want C to be present in the variable entrant. I mean to say, let us assume कि हम चाहते हैं कि जो हमारा K-map है, the K-map that I want here, if I say that K-map that I want, I have a variable A and I have a variable B, right? I can also take A and C. I can also take B and C. I can take any one of them. But for simplicity purpose, to explain the concept, I am taking A and C. तो अब यहाँ पर क्या कर सकते हैं हम लोग? So just check, whenever A and B both are having a value 0, then how this function behaves as compared to C. ये function कैसे behave कर रहा है C के respectively. So when A and B both are 0, this function is having a value 1. When A and B both are 0 and 1, this function here, it is having a value C complementation. यानी कि जो भी C की value होगी, this function will assume an opposite value. When A and B both are 1 0, then this function is having a value which is exactly equivalent to C. When A and B both are 1 1, this function is assuming a value 0. That means I can also represent it in this manner. This is variable A, this is the variable B, and this is the function. So 0 0, 0 1, 1 0, and 1 1. So when both are 0, so this function is having a value 1. at 0 1 this function is having a value c complement, at 0 1 this function is having a value c, at 0 1 this function is having a value 0. So in this manner you can represent a 3 variable k map just by using 2 variables. So this is representing your a complement and a, this is b complement and b. So I'm going to write it this way. So it is 1 c complement and here we have c and here we have 0. तो इस तरीके से आप इस फंक्शन को रिप्रेजेंट कर सकते हैं. एंड रिप्रेजेंटिंग दिस फंक्शन इज सच एन इजी टास्क. इतना बनाना इसको आसान है, राइट? In the same way, if I have a 4 variable k map, I can also represent a 4 variable k map using a 3 variable k map, and then further I can even represent that 3 variable k map to a 2 variable k map. हम कुछ ऐसा भी कर सकते हैं. Let me show you how can we do it. So here we have a 4 variable k map. यहाँ पर हमारे पास एक 4 variable का k map है. So this is your 4 variable k map, or you can say this is representing your uncompressed k map. ये आपका एक uncompressed k map है. So if I view the concept, if I try to understand the concept, अगर मैं इस 4 variable k map को लूँगा, so this 4 variable k map can also be converted to a 2 variable k map. इसको हम 2 variable k map से भी एक्सप्लेन कर सकते हैं. कैसे? देखो, in a 2 variable k map we have only 4 cells. In a 4 variable k map we have a total of 16 cells. अब देखो यहाँ पर क्या है, in this first location this a is same, right? a की वैल्यू सेम है, as well as c is having the value same, right? c की जो वैल्यू है वो भी सेम है, right? So I mean what I can do here is, instead of taking a b and c d here, I can just represent a and b, and I can change this cd and I can represent this cd as a function. हम cd को एक function की तरह से represent कर सकते हैं. What do I mean to say by this is, let me explain you कि मेरा कहने का मतलब क्या है. What do I mean to say? So here this is representing ABCD. Okay. Now in this ABCD, first of all check for when a and b both are having a value. Okay. So first of all let us convert this 4 variable to a 3 variable. सबसे पहले हम इस 4 वेरिएबल को 3 वेरिएबल में कन्वर्ट करते हैं. So what I can do is I can choose these 3 variables. So when all of these 3 are 0, then this function y is behaving as d, right? क्योंकि जो d की वैल्यू है वही फंक्शन y की भी वैल्यू है. When all of them are 00001, then this function t is having a value 1. तो इसकी वैल्यू क्या है हमारे पास? 1. When they are 010, this function is behaving exactly as d complement. तो हम यहाँ पर लिखेंगे d complement. Here when they are having a value 011, this function is giving us output as 0. When we are having this value 100, this function is behaving as 1. When we are having 101, this function is behaving as d complementation. तो ये आपके पास d complement हो जाएगा. When we are having 110, this function is behaving as d. When we are having 111, this function is behaving as a d complementation. So in this manner you can compress a 4 variable k map to a 3 variable k map. इस तरीके से आप एक 4 variable k map को 3 variable k map के अंदर compress कर सकते हैं. You can clearly see compressing this 4 variable k map to a 3 variable k map is very easy. इसको compress करना जो है वो बहुत ज़्यादा आसान है. Compressing this one is very easy. Okay. Now how can I compress it 2 times? अब हम इसको 2 बार कैसे compress कर सकते हैं? How can I really compress it 2 times? To understand how can I compress it 2 times, come back to this portion. इसको समझो कि कैसे इसको compress किया जा सकता है. So I'm going to compress the variable c and d. So I'm going to take this variable a and b. All of them are 0 here. Here we have both are 001. This is representing 10 and this is representing 11. Now look at this part. सिर्फ इस part को देखो. And for this part you can represent this part by using this k map. इस पार्ट को हम इस k map से रिप्रेजेंट कर सकते हैं. So basically what I'm trying to say here that I can make a separate k map for CD. तो CD के लिए मैं एक separate k map लूँगा and I can solve this separate k map. I can find an expression. तो अगर मैं separate k map को लेकर मैं separate k map को solve कर सकता हूँ, इससे एक expression find out कर सकता हूँ. So you will feel कि ये कैसे behave कर रहा है, how this behaving. So when both of them are 0, it is 0. 01, it is 1. 10, it is 1. 11, it is 1. So that means it is acting as a OR gate. So it is C plus D. Correct? In the second example, here it is 1000 which is representing a NOR gate. क्या represent कर रहा है ये? एक NOR gate को. So it is C plus D whole complementation. If you look at this one, now this is representing a NAND gate. AND gate का opposite. तो ये NAND gate को represent कर रहा है. That is why it is C dot D whole complementation. And if you look at this is representing an XOR gate. So that is C XOR D. So simply I can make a two variable K map here and I can represent all of these functions just by using this two variable K map. So it is very easy. I can convert a four variable K map to a three variable K map. I can also convert a four variable K map to a two variable K map, and sometime I can also convert a four variable K map to a one variable K map. इसी तरीके से if you compress it, you can even compress it further. तो इस तरीके से हम किसी के मैप को कंप्रेस भी कर सकते हैं. Now my question is how can I solve it? हम इस तरह की जो इक्वेशन है इसको कैसे सॉल्व कर सकते हैं? So this is the process. Let me explain the process step by step. हम इस प्रोसेस को एक एग्जांपल से एक्सप्लेन करने की कोशिश करेंगे. Let me explain you the same process step by step. ठीक है? So assuming that I hope it is visible. Yes, I hope it is visible. So this is D complement and this is also D complement. So this is D complement and D complement. Right. So we have this variable entrant map for the four variables A, B, C, D, and this variable D is present inside the variable entrant map. तो कैसे करना है? The first step is keep all the variables as 0 and get the expression. जितने भी variables है सबको 0 रखो और expression ले लो. So here we have D. तो जो जहाँ पर भी D आपके पास present है उन सभी लोकेशंस को हमने 0 रखा and we found the expression. So what is the expression here? Expression here is it is C A complement C. तो यहाँ से जो expression आएगी वो आएगी हमारे पास A complement C. Okay. Next, select any variable and keep it 1 and keep other variables as 0 and change every one to don't care. यानी कि जैसे यहाँ पर एक D है, देखो हमें करना क्या है? We have to assume D and D complement as two different variables. D और D complement जो है वो दो अलग-अलग variables हैं, हमको दो अलग-अलग तरीके से ट्रीट करेंगे. ठीक है? तो इस सेकंड प्रोसेस में हमें क्या करना है? सेकंड प्रोसेस में क्या करना है कि आपके पास जहाँ पर भी D है, ठीक है, जहाँ पर भी आपके पास D है, keep the D as it is. मतलब D को 1 कर दो और जहाँ पर भी D complement था उसको 0 कर दो. अगर D के अलावा कोई और वेरिएबल भी है तो उस वेरिएबल को भी 0 कर दो और जहां पर 1 था उस 1 को डोंट केयर कर दो. अब इसके लिए एक एक्सप्रेशन फाइंड आउट करो. इसके लिए एक्सप्रेशन फाइंड आउट करोगे तो सॉल्यूशन आएगा A C कॉम्प्लीमेंटेशन. ओके. एंड अगेन अब बिकॉज हमारे पास सिर्फ दो ही वेरिएबल है, यहाँ पर एक वेरिएबल है D, एक वेरिएबल है D कॉम्प्लीमेंट, इसके अलावा कोई और वेरिएबल तो है नहीं. राइट. सो आई हैव टू टेक दिस D कॉम्प्लीमेंट दिस टाइम. इस बार हम D कॉम्प्लीमेंट को 1 करेंगे, जितने भी D थे उनको 0 करेंगे और जहां पर भी हमारे पास 1 था उसको हम डोंट केयर करेंगे. एंड आफ्टर दिस आई विल गेट एन एक्सप्रेशन इज C. अब उसके बाद करना क्या है? ये जो प्रोसेस है हमें हर एक वेरिएबल के रिपीट करनी है. राइट. बिकॉज आई रिपीट द सेम प्रोसेस फॉर D एंड D कॉम्प्लीमेंट सेपरेटली. हमने दोनों के लिए इस प्रोसेस को रिपीट किया. नेक्स्ट, SOP ऑफ वेरिएबल इज ऑब्टेन्ड बाय ऑरिंग द प्रीवियस SOP एक्सप्रेशंस. ठीक है. अब देखो यहाँ पर क्या है कि ये जो एक्सप्रेशन थी, दिस एक्सप्रेशन आई क्रिएटेड फॉर D एंड दिस फंक्शन, दिस वेरिएबल आई क्रिएटेड फॉर D कॉम्प्लीमेंटेशन. सो बेसिकली मुझे क्या करना है? आई हैव टू कंबाइन दिस D विद A C कॉम्प्लीमेंटेशन एंड आई हैव टू कंबाइन दिस D कॉम्प्लीमेंट विद C. आफ्टर कंबाइनिंग इट व्हाट इज द एक्सप्रेशन आई विल गेट? दिस इज द एक्सप्रेशन आई विल गेट. मुझे ये एक्सप्रेशन मिलेगी. ओके. हाउ आई गॉट इट? दिस A कॉम्प्लीमेंट C इज फ्रॉम दिस मैप, क्योंकि इस मैप में हमने सभी 1 को लिया था और जितने भी D थे उन सबको 0 एज्यूम किया. दिस A C कॉम्प्लीमेंट D इज फ्रॉम दिस मैप, क्योंकि ये जो था इसके अंदर हमने D को 1 लिया था और बाकी सभी वेरिएबल्स को 0 लिया था और 1 को डोंट केयर लिया था. तो यहाँ से A C कॉम्प्लीमेंट आई थी, तो इस A C कॉम्प्लीमेंट को D के साथ कंबाइन करो, देन इट इज A C कॉम्प्लीमेंट D. और ये जो एक्सप्रेशन है दिस इज फ्रॉम दिस के मैप. यहाँ पर जो एक्सप्रेशन थी वो C थी. अब C हमारे पास आया था, सो हमने क्या किया? बिकॉज ये डी कॉम्प्लीमेंट के लिए हमने बनाया था, यहाँ पर डी कॉम्प्लीमेंट वेरिएबल को हमने 1 एज्यूम किया था, सो इट इज सी डी कॉम्प्लीमेंटेशन. सो दिस इज योर एक्सप्रेशन. सो इन दिस मैनर इफ यू हैव अ वेरिएबल एंटर्ड मैप, आप वेरिएबल एंटर्ड मैप को भी इजीली सॉल्व कर सकते हैं. यू कैन इजीली सॉल्व अ वेरिएबल एंटर्ड मैप जस्ट बाय यूजिंग दिस टेक्निक. ओके, आई होप यू अंडरस्टूड एंड बाय दिस वी हैव कंप्लीटेड योर के मैप्स. तो इस टॉपिक के बाद हमने के मैप को प्रॉपरली कंप्लीट कर लिया है. वी हैव कंप्लीटेड ऑल द टॉपिक्स ऑफ के मैप. नाउ इट इज अप टू यू टू प्रैक्टिस द क्वेश्चंस एज वेल एज सॉल्व प्रीवियस ईयर गेट क्वेश्चंस. ओके, एंड हियर दीज आर सम ऑफ द क्वेश्चंस दैट आर फॉर योर प्रैक्टिस. इन क्वेश्चंस को आप सॉल्व कर सकते हैं एंड देन let me know if you face any doubts or difficulty. These questions are for your practice purpose. ठीक है? Thank you so much for watching. Let us meet in the next topic.